listening to the MycoGeeky Podcast.
All right, what's up, everybody? Welcome to the MycoGeeky Podcast, the podcast that goes deep so you can level up your at-home mushroom cultivation game. I'm your host, MycoGeeky, and tonight we are going to get a little more geeky than usual. We've done it before. We're going to do it again, but tonight we're definitely doing it. We're going to talk about fungal barcoding, DNA sequencing of fungi, the macrofungi, basidiocarps. Just as far as the eye can see, that's what we're talking about. C's and T's and G's and A's. We're going to get into it tonight. I found the pros, the best of the best I could find online, and we're going to try to pick their brains and see what life's like sequencing mushrooms. So anyway, so what I'm going to do is bring everybody on. And we'll do a little introduction, and then we'll do roundtable at that point. So first off, let me just give a quick shout out to all my people on my Discord. I love you guys. You guys are great. And all my Patreon supporters, I appreciate you guys. You guys help pay the bills and allow me to keep just tweaking the show a little bit, get a little bit better every episode. So anyway, real quick, Patreon.com, MycoGeeky. Please consider supporting the show. I'd appreciate it. All right, so let's bring these guys on. We're doing one thing tonight, guys. If you want to talk about cubes, we're probably barely going to be talking about cubes tonight. It's going to be about sequencing fungi. It's going to stay geeky, like I said. All right, so let me bring everybody on here. So first up, this guy, he runs a couple Facebook groups. That's how I first was aware of his existence. He, along with one of our other guests, utilizes a very new way of sequencing DNA, and we're going to talk about that as well. Let me welcome to the show Stephen Russell. What's up, brother?
Hello, thanks for having me here.
Oh, thanks for being here. I appreciate it. All right, so next up, we're just going to bring everybody on. I'm trying to remember who. All right, next up. All right, so this guy, he does everything. He's out in the woods. He's in the lab. He's getting an education and doing some educating. He's truly an amateur mycologist who is a great advocate and really helps spread this infectious love that we all have for mushrooms. Welcome to the show, Harte Singer. What's up, brother?
How's it going?
Good, man. Thanks for being here.
My pleasure.
All right, let me keep going here. Next up. All right, so I'm not even going to lie. I see comments here and there from this guy on Facebook, and I'm like, this guy knows his stuff. This guy's good. He's not out there being flashy that I can see, at least on Facebook, but I could tell he knew what he was talking about. I did a little research, found out he knows a whole lot of stuff. So we're going to get to know him a little bit better and find out his areas of expertise. But for sure, he loves mushrooms. Welcome to the show, Damon. And let me see if I'm saying this right. Tighe?
You nailed it. Most people miss that. Yeah, my name is Damon Tighe. Happy to be here, especially with this crowd. Super good folks in this room tonight.
Awesome, man. Cool. Okay, last but not least, he's a fellow hometown boy for me. He lives a little bit south of me, but he is very enthusiastic about mushrooms. He gets me enthused, and I'm usually the one doing the getting people excited. So I really like this guy. Very excited to have him on. Kyle Canan. What's up, brother?
How's it going?
Good, man. Thanks for being here.
Yeah.
So when Kyle's not sequencing mushrooms, he's like a wrestling coach. He's got kids. They all wrestle. His kids can probably kick my butt. I'm going to be honest. They're like winning state championships every other weekend. It's cool to see you know more of you. So on that note, I know a lot of people tuning in probably are familiar with some or all of you guys. Some people probably have no idea who you guys are. So what I want to do is go one by one, give everybody watching a chance to either get to know you for the first time or get to know you a little bit better beyond what they just know about some of the stuff that you guys do online. So I think let's just start off with Steve. So I'm going to pull everybody else off, and then Steve and I will chit-chat for a while. I'm thinking 10 to 15 minutes, and we'll just go through everybody, and then we'll bring everybody back on. So, all right, let me pull. I got a little overlay for you. There we go. All right, man. I want to start with you,
Yes.
mostly because I see you, man. I see you you're putting in a lot of work. You're doing some good stuff. You're doing some thankless work. And it wasn't until I was talking to Kyle and learning a little bit more about Nanopore that I realized like what a ballsy, cool move it is that you are taking this so seriously, because I really do think it's exciting stuff. I'm sure you do too. That's why you're doing it. But before we get into Nanopore, just tell people who you are, your maybe scientific or educational background, and how you eventually got into this space. Like, how did you go from not doing anything at all with mushrooms to doing everything with them?
Yeah, sure. So, I don't have a story where I was growing up and always was in the woods hunting mushrooms or anything like that.
Okay.
I actually got into mushrooms probably like a lot of people did in the college arena. I actually started as a mushroom cultivator, so I grew mushrooms for probably about 10 years or so. Throughout the 2000s. Ended up writing a book on mushroom cultivation in, it was published in 2014 now. And that was kind of the end of my cultivation experience. So I grew mushrooms for a while and then kind of made a transition over into wild species and learning about everything in the woods.
Okay.
And so, I started the Hoosier Mushroom Society. Hoosier somebody from Indiana. And so that's been my focus most of this time is the biodiversity of Indiana mushrooms. Since probably about, I think 2009 is when we started the Hoosier Mushroom Society, and so that's when I kind of started to transition away from mostly a cultivation interest over towards a biodiversity interest and trying to learn everything that's out in nature.
Nice. So let's talk a little bit about the book. So you were growing, what kind of mushrooms were you growing? Every gourmet under the sun? Were you trying, paint a picture.
All kinds of species. So I actually tried my hand at mushroom-related business there for a while. Maybe back in 2000 and maybe 2008 to 2010, somewhere in that arena. I found that to be interesting, and I'd still like to make a living off mushrooms. But it's especially early, over a decade ago now. Well, getting there. I just didn't think it was going to get me to the end result that I wanted to be in.
Okay.
So I kind of transitioned away from that and just took a more normal course with my professional development.
Cool.
So I have a normal day job, outside of mushrooms. Actually going to be switching jobs here soon. But I've always enjoyed mushrooms, but primarily as a hobby at this point. But as it's is so much more than a hobby, even though it's a hobby. It's more like a second and third full-time job.
Right. I understand that. So, so a lot of people grow mushrooms, but not a lot of people write books. So, what made you decide to write a book? I mean, that's really cool.
Yeah, I just learned a lot over a decade of growing mushrooms that I wanted to tell people about. Just kind of summarize my experience with it, especially since I wasn't really planning on cultivating much in the future, and my interests were kind of shifting. I figured, hey, why not? I actually started writing the book. I got inspired to do it at Telluride Mushroom Festival, and so I was actually sitting at the bus stop, waiting for like a bus back to Durango or something to catch my flight, and just kind of wrote out the first 2 chapters of the book longhand on pen and paper, and that's kind of how it started, and finished it off shortly after. So
that's a cool story. Maybe I need to go to Telluride and see what I get inspired to do over there.
Yeah, it's pretty good for some inspiration.
That's great. Now, for my viewers, just so you guys know, it's a really well-reviewed book. I mean, this, like, it's go to Amazon, The Essential Guide to Cultivating Mushrooms. Lots of 5-star reviews. So just kudos for you. I think that's great. One of the things I always advocate for is, if you're a part of a community, figuring out how you can not just be a placeholder in the community, but how you can give back to the community. So I think that's very cool, and I think that sort of translates into really a lot of what you're doing now. So you go from cultivation, you write the book, and then you're like, okay, I did it. I learned how to cultivate. I wrote a book. I got to do something else. I need more. I know that feeling. So you get into, was your next step, besides the professional work and all that, but your next step in mushrooms, was it sequencing, or was there
No, it was really just kind of getting out in the woods and learning all the wild species. So trying to be a really good field identifier. And so, within recent years, my field identification skills have started to noticeably wane since I've, been spending so much time in the laboratory relative to out in the woods. But that's really still where my passions primarily lie, is just, being out in the woods and exploring and seeing what I can find. And so, I still lead lots of walks, even just yesterday. We did a morel walk here in Indiana. Cool. And so I probably lead, 10 or 12 walks a year still for field identification for people. And so I still make that a pretty big part of what I do, and just try to teach people as much as I can about field ID. But yeah, that's probably really my main driver in sequencing in general. Isn't so much as, the sequencing technologies or, understanding, the science of DNA per se. It's really the underlying rationale for it all is knowing what's out there, being able to identify more precisely what I find.
I like it. So a little bit later we'll talk about this more, because there's the old-fashioned way, which was Grandpa, he or Uncle Bill, he knew what mushrooms he could eat and what ones he couldn't, and maybe he knew the Latin names for features and things like this, or the scientific names, and maybe he didn't. But there was definitely an old way of doing it, and then now you are, I feel like, absolutely embracing the newest and latest, greatest ways of identifying mushrooms. So we'll get into that a little bit later.
Sure.
So what else do you do besides roam around the woods and extrapolate data and put them into Excel spreadsheets? Let's talk a little bit, just on a personal level. What do you like to do beyond mushrooms?
Yeah, I would say mushrooms take up a significant portion of my time in a general sense. In terms of other hobbies, I really enjoy whiskey collecting. So, I'm kind of a whiskey connoisseur, and always looking to try interesting whiskeys. So
nice.
That's I would say that's my other main hobby.
Now, have you ever actually tried to distill it?
Not personally. I think I made wine in the past or something. Maybe beer once or twice, but I've never tried to distill any spirits.
Well, that's the next one. Once you get Nanopore locked down and you write the definitive guide on it, that's the next step, distilling whiskey. All right, man. Well, thanks very much. We're going to move on to our next guest, and then we'll see you back on here in a bit, all right?
Sounds great.
All right. Let me... All right, guys. So next up, Harte Singer. Here we go. Let me pull up the overlay. Okay. All right, brother. Thanks for being here.
Oh, my pleasure.
So similar to what we just did with Steve, how about you just walk me through kind of just your background? A lot of times with my cube growers, I say, tell me your myco origin story. Like what was that early thing that got you into mushrooms?
Yeah, for sure. I definitely wasn't always a mushroom nerd. I had a career in the restaurant business. I started cooking when I was 16 and worked my way up in restaurants in New York. And there was one summer where I was working out in the Hamptons, and it's like a fancy town out in Long Island. And I had no friends out there, nothing to do. And so when I wasn't working, I went for a hike, and I remember finding this patch of black trumpets. And I was like, oh, these are the same things that we get at work. And I looked up a bunch of ID things on the internet. This was before Facebook, so there wasn't any Facebook groups or anything. And And I was pretty sure that I ID'd them correctly, but I ate them and I was still terrified afterwards.
Right.
Lying in bed, shaking, like, oh, did I poison myself? Woke up the next day, was still alive, so that was quite a thrill. I kept doing it, and after a certain point, I got really curious about, one, what are they doing out there? What's their whole purpose? And then what about all these other ones that I can't eat? So that kind of developed for a while, and when I turned 30, I decided I was done with the restaurant business. I wanted to transition out, and I never saw myself getting into mycology. It was just kind of a hobby. I was really fortunate in that I was able to meet a lot of really great people in this community. A couple of whom are here on this podcast tonight.
That's awesome.
Damon Tighe was definitely a strong influence in my decision to get into more of the scientific side of things. And I went to a talk with Alan Rockefeller in 2018. He was doing the psilocybin mushrooms of Mexico talk, and then afterwards he invited everyone over to his lab at Counterculture Labs. It's like a big old community lab space in Oakland, and that's where he does all of his work out of. And he was showing people how he does PCR to identify mushrooms, or at least to investigate mushrooms. And I thought that was really fascinating. So I hung out and ended up going on a hike with him the next day and just kind of followed him around for a while until I became his sort of de facto lab assistant for a good portion of time. And so, the confluence of all those forces kind of led me to be where I am, and I'm really just standing on the shoulder of giants. My accomplishments are meager compared to them, but I'm proud to be their progeny.
That's awesome. So you're NorCal, is that right?
Oh yeah.
Okay. So you're up in that area.
Yeah, I'm in Sonoma County, but I spend a lot of time down in the Bay. Originally from New York, moved out here in 2012.
So at least in the cultivation community, there's definitely a pretty significant amount of people have a background either in some sort of lab work or in the kitchen. It's fascinating how the kitchen seems to draw a lot of people to mycology. And then both the kitchen also seems to inform their cultivation abilities and all that. So maybe we'll talk a little bit later about some of that stuff. But yeah, so the first time we had any formal conversation was when I was first trying to gear up for barcoding and bought a few things off you. You want to talk a little bit about how you went from being Alan's original Mindy Quark to turning into a guy who runs a business and helps amateur, citizen scientist type people source primers and things like that. Like, how did that come about?
Yeah, so that came about kind of as a result and a consequence of my mycological upbringing. I learned from Alan at Counterculture Labs and ended up sort of inheriting a lot of the work that he was doing when he went to Mexico. Okay. So there was one summer when he had a bag of David Aurora's mushrooms. David Aurora is a famous California mycologist, and I did some sequencing on those. And then he got hired by a company called Mimosa Therapeutics, and I ended up helping him on that end. And so I always wanted to be able to return the favor of having giving out this knowledge and experience to people who are willing to take it on. I also ran into a situation during COVID when I didn't have access to a lot of the resources that I needed to do this work. Counterculture Labs was closed. This was before Alan and Mimosa, so it was really kind of a pain in the butt to get supplies, to get reagents. And I started doing a lot of lab work at home, and I got this idea. The best way for me to get some of these things is just to start an LLC. So it was more of a selfish move, to be honest, so that I had a pathway to buy certain chemicals that you can't get as a private citizen.
Right.
But so it was never an entrepreneurship type of situation. It was mostly to solve a problem that I had. But I thought, well, if I'm going to be buying, bulk batches of master mix and primers, and I know there's a lot of folks out there that want to get started with this type of activity, I might as well, offer to break off little bits of what I'm buying and sell them for super cheap. I'm not really trying to make money off of anything here. So that's kind of the inspiration for Dikarya LLC. And I do sequencing for the Sonoma County Mycological Association. I do a lot of work with the Entheogen Genome Project, and my LLC serves as a sort of conduit for that sort of work to take place.
That's great. So now, how long has that business been going?
For about a year. I think I started it last February.
That's great. Cool, man. So I know you also do you do workshops and sort of outreach, beyond just providing some of these hard to get tiny minuscule tubes of very rare and specific liquid. So talk maybe a little bit about some of that outreach that you do. I know you're still affiliated with Counterculture Labs, right?
Yeah, that's correct. So I'm a part of a mycological association called Bay Area Applied Mycology. Okay. And I sort of use that as another venue in conjunction with Counterculture Labs to teach some workshops. So it's kind of like provide content for the members of this organization. I'm on the board of directors, so it's kind of like, I have this need to further this organization. So I'll do classes for Bay Area Applied Mycology members at a discount, and then to the general public at Counterculture Labs. I just did a series on cultivation, so it's not my prime focus, but I'm also a cultivator. And so taught people how to take mushrooms from the wild, put them on agar, take them to grain spawn, take them to bulk substrate, and it's a series. And I'll be doing another class on DNA barcoding, which is a little bit more involved, and that'll be in May. Nice. But I did a large workshop at SOMA Camp. So the Sonoma County Mycological Association, abbreviated as SOMA, has a really awesome festival every year in Sonoma County. And I did a 2-day DNA barcoding workshop there. We found some really cool stuff, including an undescribed cordyceps species, which we ran through this entire pipeline of microscopy, culturing, and sequencing, all there at this mushroom festival. So I thought that was kind of a cool little gimmick.
It's like the perfect outcome on that. That's great.
It's right.
That's great. If I do a workshop and I'm going to roam around and find some mushrooms and sequence them, I mean, that would be great to find something that nobody sequenced before.
Yeah, I think I've even bigger aspirations for next year because I'll have nanopore sequencing, so I can essentially get data in almost real time. But we could then describe it there too. We have some really excellent mycologists that show up there who've done hundreds of species descriptions, and their biggest complaint is that everyone's sequencing things but no one's describing mushrooms. And I'm like, well, you got this venue, let's do it. So
that's so cool. So you are also, are you purchasing one, or is the right person going to show up with theirs?
For a nanopore, I have one.
You got one too. Oh my god! I didn't realize I was doing a nanopore podcast. Okay, this is cool.
Well,
nice.
Well, I've been following Steven. I've been thinking about doing nanopore for a long time, but I'm very timid about it. I'm not as confident in my learning abilities, self-learning abilities. So I always like to watch and let someone else have a hard time before I do. And Steven was
I love doing that.
To do that. Yeah.
Yeah, I'm like, I love watching Steven figure it out. Yes, I agree.
Yeah. Even with his extremely well put together protocol, I'm still managing to screw things up, but I'm almost there.
Right. Well, for the audience, before the podcast started, we were all chit-chatting, and Ed had made a comment about training some people on DNA sequencing, and he said that despite, just doing everything right, he's literally watching these people try to do it right. Somehow it just didn't work out. So who knows? Maybe just one thing has to click or something like that, and that's all it takes. Or maybe it's just still tricky. I mean, I see Steve's posts every once in a while. He does a run and he's like, I don't know what happened. So we'll now that I know there's so many Nanopore guys here, we'll definitely spend some time talking about Nanopore and the ups and downs, trials and tribulations, and all that good stuff for sure. Cool, man. Well, really glad to have you here. I'm going to keep going with the last two guys, and we'll meet you back here in a second for the roundtable.
Sounds good.
All right, so next up, like I said, he didn't have a YouTube channel. He wasn't pushing himself or promoting himself through various means. He didn't have that I know of. Maybe I'm wrong. Anyway, he wasn't necessarily on my radar, other than I just noticed this guy had really smart comments when he made comments in some of the Facebook groups that I would see him on. And ended up discovering that he knows a couple things. So we're going to bring him on, and we're going to find out a little bit more about Damon Tighe. What's up, man?
Hey, what's up, brother?
All right, let me pull your overlay up. Okay, now you're real. There it is.
All right.
Now you're official. All right, man. So just like I did with some of the other guys here, I'd love. I know you are more broadly. It's not just mushrooms for you, which is cool. I'm not just a mushroom lover, although that's where most of my obsession lies right now. But yeah, just give us maybe like your myco origin story, but also I think for you maybe a little more broadly your love for biology in general.
Okay. My mushroom origin story kind of comes back a little bit like Hart's, actually. It was kind of food motivated. I was doing a real long trail in California, the Jawmere Trail, which runs about 220 miles down the spine of the Sierra Nevada. And it'd been the first time I'd gone backpacking for more than 2 days, so I did my calorie calculations wrong and was about 2 days short on food and really hungry. And I remember seeing mushrooms on the side of the trail and just being like, I wish I knew I could eat that. And so I made it a big thing that when I got back home to just try to at least learn to identify something I could eat. And then I think within that same year I got home, found my first California chanterelle under some like oak trees, and kind of similar to Hart, took it home, cooked it all up. No one had seen one before, but then you have that first bite and you're like, oh yeah, I definitely poisoned myself. And then so like sat there for hours, like feeling every single little pulse in my face, going to sleep, waking up and being like, oh, I'm still here. All right. Ate the rest of it, and then it's been a love affair ever since. But I've got this really broad interest in just biology, biodiversity in general. I think that's part that I grew up like in the super sticks. I know when people hear about California, they're like, oh, you grew up near the coast and the redwoods. And I'm like, I saw the coast once in my life through high school, and I grew up in a cow town. But that just meant that I was outside all the time, like seeing nature every day. And so that just kind of continued on into where I'm at right now. And so probably the easiest way to tell I have a giant interest in biodiversity is my use of that community science platform known as iNaturalist. You basically can take your cell phone, take a picture of an organism, upload to a global database. People can help you figure out what it is. And while you're doing that, it grabs your GPS and a timestamp. And so we're basically rebuilding species biogeography maps. So some people go out and they photograph their favorite mushrooms and stuff like that, and I do that too. But I've done that about 76,000 times, so I obviously am a little OCD in this arena and just love just trying to figure out. I mean, I could just go out in my backyard and spend an entire life there just trying to figure out what's there and name it, let alone let me loose on like a real forest and now you're not going to see me for a month. So I've been using that platform a lot. I really love being out in the woods, like Steven said, getting out there and seeing stuff, and so combination of iNaturalist and that kind of OCD behavior, I've ended up doing like a lot of like surveys outside of California, like for fungi. So I did probably the most intriguing one for me was I did one in the Andes for Ecominga reserves in Ecuador, and that was basically like 3 weeks of just sloshing around in the high Andes in the wet cold, documenting mushrooms for them, and it was just phenomenal. Just to be able to see stuff that people have not seen and put names on for sure. Unlike the stuff in California where we've probably seen a lot of it, but just are using the wrong names because we haven't had these molecular tools to really help us point that, hey, you know what, we've got something that's different than what's in Europe, and we've been using these wrong names for a long period of time. So that's kind of like a little bit of like the origin story. I also do a little bit of cultivation on the side, but that's mainly to work with like basically carbon scraps around like my household. So basically anything coming from the kitchen, anything coming from bushes, I like to process it with oyster mushrooms, hericium, and things like that to get a little bit of food off of it, but then that also goes right into the compost, so that way you get this nice kind of carbon cycle, basically building a little ecosystem like on the place that I live. So I got a little bit under the belt, but unlike Hart, I don't know where that guy finds the time to do so much teaching. I do a little bit through the California Center for Natural History, which is a nonprofit that I help run. I do like walk and talks, but haven't really helped in the cultivation arena for a while because the Bay Area is really well saturated with a lot of people doing that, thankfully, and really fantastic folk like Hart doing it really well.
That's awesome. All right, so what's your day job? What do you do when you're not obsessing over mushrooms and doing iNaturalist entries?
So I work in biotech, and that was always like my interest in kind of college and stuff like that. I thought I wanted to be a doctor like in high school, and I went and I worked for a surgeon, and I was like, oh my God, hospitals are just not my thing. I know for some people that is your thing, but the clinical environment just wasn't for me. So I was like, figured out I wanted to be a research scientist doing primary research, and I ended up working on the Human Genome Project through the national labs. And so that's why I learned DNA sequencing, was by basically processing literally thousands of samples every day using the Sanger method, which is the old school method now for doing DNA sequencing. So did the Human Genome Project and then pushed on from there within the national labs to figure out how do we sequence single microbial cells. When we think about the biodiversity of the planet, we don't know jack shit because most of it we can't culture, most of it is microbes. And so the only way we could really figure that out is if we could capture cells and then basically read the DNA inside of them to figure out who they are and what they're doing. And so I helped pioneer a process for doing that, where we literally capture single cells with a glass capillary, chemically lyse them open, amplify the entire genome so that we could then do full genome sequencing. And so that's kind of what my day job was for a long chunk of time. And then I combined that with a previous kind of world where I was a high school teacher. And so now I actually teach biotech to high school teachers and to community college profs. So that's really cool because I can kind of push a lot of this kind of primary research now into high school, into community college. And so I'm helping a lot of them learn to do DNA barcoding, things like that. So the more people we can have doing this, the better a chance we are going to have at being able to actually put names on things. Remember, that's the starting block.
That's the start.
You got to name stuff and then start talking about what these things do together. How do we build ecologies? But we got to start by being able to say, hey, here's the players. And so that's what I'm really excited about doing from the education side of it.
Yeah, man. You got to know who LeBron James is before you know you need to throw the ball at him, right? Like, yes.
That's right.
Yes. And there's a lot of stuff out there. I heard there's a bunch of bacteria. It's all out there.
It's crazy. And it makes it such a big deal, right? It's like, if you stripped us of our bacteria, you don't exist. What's in your gut actually causes a lot of what goes on in your neurology.
Oh, yeah.
They produce a lot of your neurotransmitters and stuff like that. And so it's just, it's a wild world. And these jumps in technologies that, some of these guys we're going to talk with tonight are doing, this is what's allowing us to see a lot of this. The nanopore sequencing that Stephen, Hart, and Kyle are now doing, like, this is what's going to allow us to do that next big jump of where we can start taking on more of these organisms and looking at them, which is huge, because it's also going to start to change the way that we think about looking at them. So instead of looking at one little section of them, we'll look at multiple sections, and then at some place down the road, I'm not sure if it's going to be with this technology, we're going to look at their whole genomes to do comparisons. And that's already going on in bacteria, and I think it's just around the corner for doing that in fungi. And I wouldn't be surprised if, at least from the community science point of view, some of the people in this room are going to be big players in that happening.
It's exciting, man. So there's a lot of science that happens, and there's not an amateur component to it. At least maybe not 20 years ago. Maybe you get a little bit more of that these days with DNA and CRISPR and all that. and maybe you just have like a random guy that's obsessed with chemistry and, you know, read a bunch of books or something. But for the most part, right, the bulk of science occurs after you get a Ph.D. and work with the university and then get hired, you know, private sector and all this stuff. But mycology is really fascinating. Maybe some other ecology and biology. But there's really, for me, at least my assessment, is you have these non-academic mycologists. You know, they love mushrooms. They're obsessed with mushrooms. They might not be using the correct terms all the time, or maybe they are. Sometimes they really are. And then you have the, you know, academic mycologists. And I think it's a fascinating time because I think we're going to start seeing, given the amount of work that needs to occur and the amount of potential that could exist from the fungi kingdom, I think it's going to be cool to see potentially citizen scientists turn into academic scientists, or academic scientists working more with citizen scientists, just having the end goal be to actually do more research. So I think it's really cool to have you guys on, get exposed to some of my community that I talk to who are definitely, you know, growing mushrooms in their basement or out foraging and, you know, growing stuff in buckets and stuff like that. Just getting to hear a little bit about what you guys do, and like you said, bringing, you know, some of that story into community colleges or high schools. I think that's really crucial.
Yeah, and I think it'll be interesting too, because I think the first wave is going to be a lot of like the folks you have in this room where we're interested in the biodiversity. But I think we'll get a lot of those folks that are more in your kind of classic cultivators group that will eventually get into genomics because they want to understand what gives me this phenotype, what gives me this chemotype, and then can I get in there and manipulate it? I mean, especially with how accessible CRISPR is these days.
Right.
I mean, I'm surprised that I have not seen a deluge of cube cultivators getting in there with CRISPR to really kind of amp up different pathways. But I would say in the next 5 years.
I was going to say 5 years, dude. We'll
Yep.
just give it a couple more years. We'll
For
be
sure.
there for sure. Cool, man. Well, thank you so much. I'm gonna get to Kyle here, and then we'll bring everybody back in. All right. Last but not least, fellow Ohioan, Kyle Canan. What's up, brother?
How's it going?
Good, man. All right, so I already know you're actually, I have most familiarity with you for this evening. So for everybody else, tell everybody a little bit about yourself and how you got into being just completely obsessed with mushrooms like the rest of us.
Cool. Yeah. Thanks for having me on, first off. So just like everyone else, I didn't always have a love for mushrooms and mycology. As a matter of fact, I'm kind of new to it. 2019, 2020 is when I really started diving deep into, mycology. I've always battled autoimmune deficiency, and being on different medications for that haven't always been the best for me. So I kind of don't remember how I heard it, but I heard that there was, a medicinal mushroom called turkey tail, Trametes versicolor, that had properties in it that could help with act as an anti-inflammatory. And I was like, what? And I just started digging into it from there, and kind of just going out and exploring, finding, a mushroom here and there, and then just working on all the basic beginner things of field ID and all that good stuff. So it's, it's recent for me. And then I think one thing just kind of led to another to where I'm here now with my little lab here at home.
Nice. So, well, we're kind of similar in that we saw the medicinal promise or a hope in mushrooms to provide us something medicinally that big pharma maybe wasn't able to provide. So I think that's very cool. I think there's a lot of people like you. I think there's a lot of people like you and me who just don't even know yet. It's just not even on their radar yet. And I think with the new, mushrooms are like, if orange is the new black, mushrooms are the new, I don't know, whatever's the hot new thing, right?
Yeah, it is. I feel like we're definitely in the new trend of mushrooms right now.
Yes. All right. So, and then you are in school right now for, is it environmental science?
Yeah, that's correct. Yep.
So you're finishing up a degree in environmental science.
Yep.
You've been involved with some local nonprofits, and then right now you have a personal agenda to sequence the fungal biodiversity within the entire state of Ohio. Is that correct?
Yeah, that's correct. Yeah, so I'm part of the Ohio Mushroom Society. I joined that like when I was, really getting into mushrooms in the beginning, and I since worked my way up to the board. And everybody on this show, all the guys that you're having on, every one of them inspired me in different ways. And I was like, well, there's no one in Ohio that I know that's doing this, and it just seems really cool. So I kind of got into it on my own, but, inspired by all these guys. And, yeah, kind of lost what I was going to say.
No, that's great. So your original interest was turkey tail, and then
Yep.
I think pretty much everybody's telling a similar story where whatever motivated it, whether it was running out of food on the John Muir Trail or just seeing something that looked like it, was something that they used in the kitchen. For some reason, there was a desire to know what the mushroom was.
Correct.
Which makes sense because, man, we're all just, maybe this will be different for the new generation now, but I definitely grew up being told mushrooms bad. You can look at them, but don't touch them. My parents didn't even want me touching them. And then I had an uncle who took me out foraging, and he knew it was okay if the uncle showed you, this mushroom, you could eat this one, but
Yeah. I can relate to that.
no trust in themselves, that's for sure. So I feel like that's changing, but that story is the same, which is like a desire to know what it is. Can I eat it? And if I can't eat it, what is it? Why can't I eat it? So I think that's very cool. That's these days, man, I don't know. I'm noticing on Instagram, people just want to know about a certain thing, right? They want to get obsessed with a certain thing, and it can be real specific. And for whatever reason, we've just got these great people like Alan Rockefeller who are creating great digital content, and you're just like, oh, I guess I'm going to be obsessed with mushroom identification now because it's making it look cool and fun. And I like to, lots of people like to go hiking, and so I think that's really cool. And it's just tremendous what all you guys are doing, because you guys are really ushering in this new generation, a new way of thinking about science, which is getting it down to that, Damon's a part of mapping the entire human genome. Just got it done. Look, we know more than get it done. Then now we're just going crazy left and right. All sorts of interesting research is happening. So
Right. It is a good time.
It's pretty fun. Now, I know you just purchased, I wanted to call it a minion. I still do.
An ion, yeah.
But it's a min ion. It's a Nanopore, Oxford Nanopore technology. It's basically a portable DNA sequencer, because why not, right?
Right.
We,
Why not?
we live in the future.
Sequence on the road in the van.
Why
Right.
not? Why not?
Right.
I don't need to mail it in. I'm just going to do it wherever I'm at. That's great.
That's the exciting part, really. Yeah.
So we're going to talk about that, but for now, let me bring everybody back in,
Okay.
and we're going to kind of get the roundtable going here. All right, guys. So now that we got to know them a little bit, we're going to bring them all back in, and we're going to powwow. We're going to get down and dirty with DNA sequencing of mushrooms. All right. Okay, guys. Thanks for walking through that process. I know there's a little bit of waiting there. I appreciate that. So my first question to all you guys: why do you sequence mushrooms? Why do you now, right now, in this moment? What keeps you doing it? Why does it matter to you guys? Maybe just start off the top here with Steve.
Yeah, for me, the primary reason I do it is because, coming to the realization when working with field identification is that most identifications in most field guides are not correct. So, there's a differentiation between accuracy and precision. So they're accurate from the sense of it's in that group, it's closely related to what they're calling it in the field guide. But I would say most of the identifications in most field guides are not going to end up being the name that withstands the test of time. And so, coming to that realization, and then on top of that, looking at all the things that are out in nature that aren't in field guides, that aren't in any field guides. So the discovery of something new would be the other key feature for me.
So, like improving accuracy and that sense of discovery.
Yep.
Nice. All right. How about you, Hart? Why keep doing it?
Yeah, I mean, I wouldn't say my answer is going to be all that different. Living in California, we're in one of the most biodiverse places, at least from a plant perspective, and where you have plant diversity and habitat diversity, of fungal diversity, and it's a fairly good yardstick to figure out how many mushrooms you have, and so it's just trying to answer that question of how many different species are there. What are they associating with? What's their deal? And it's a curiosity that will keep me going for a while. Nice.
All right, so Damon, same question, but maybe address this. Since Hart just brought up, knowing what's out there. I'll ask you this. Anybody can jump in on it, but I'll ask you this specifically. Why does it matter knowing what's out there? Why? Who cares? Why should we know everything that's out there?
Yeah, there's a couple different reasons to want to know. So there is if I know what it is, I can then hopefully understand what it's doing in the ecosystem if I'm concerned about my ecosystems continuing on, right? And so that there's like some conservation that can be done once you can identify something, right? We've even seen that there's a couple folks right now trying to get some fungi on like the IUCN, like red list, that can then mobilize legal conservation stuff, right? So from like a policy side, there's that whole side of it. Right. Since a number of us got in here because we liked putting fungi in our mouths, it can even kind of help you understand that. So I remember a couple years back, we have this red pored bolete in California, which I'm going to butcher the Latin name on, and that's just what we do as field mycologists. So Soelos amygdalinus. And usually common, rule of thumb is you don't eat any of these red pored boletes because they're dangerous. So nobody's really been eating this one in California. Somebody did sequencing, finally got put it in the appropriate genera where it's supposed to be. And if you looked then taxonomically, you're like, hey, that should be safe to eat. And that definitely encouraged some of us to then start cutting that up, putting it on a plate and saying, hey, this isn't too bad. And so that DNA can also help you see things from an evolutionary relationship that then allows you to get things you might want out of the fungal kingdom, which might be food, it might be pharmacology, all kinds of stuff.
That's a great story of the way that the old way of identifying is you've just lumped everything into the bolete category going, well, I can't eat that. But then using this new technology, go, oh, well, it's a bolete, or it looks like a bolete, but maybe we can eat it. That's cool. All right, what about you, Kyle? Why? Because you're just like ramping up, right? You're just doing it. So, talk to me about your motivation. Why does this get you excited?
Yeah. So first, the whole reason I got into sequencing and what inspired me to do was I found I was one of the observers of the new psilocybe species that Alan Rockefeller's working on naming. So when I found that, and then got it sequenced by Alan, and then I think Stephen as well. That really inspired me. So I was like, okay, I want to try to do this stuff on my own. And the other reason was I was like, well, if I found this, new species, what's the opportunities for more? And I'm part of the old growth forest network, so I'm constantly going around counties and chasing old growth forests. So most of the forests I am in, are old growth forests. So, good summers, with rain and stuff, I find a lot of species. And before I was into collecting, I passed all of those up, and now I'm like, I'll never do that again. So it's just, I know that the possibilities are endless, and then there's nobody in Ohio that I'm aware of that is doing it. So I kind of picked up on that. We have the Appalachian Mountains, so I feel like there's a lot of diversity there. And then it's just doing the same thing all these other guys said, just uncovering the diversity. It's like a game to me, really. It's like a big hobby, so it's really interesting and fun, and I see myself being able to stick with it and have fun for a while. So why not stay doing it?
That's awesome. There's a little Pokemon factor, right?
Kinda, yeah.
It's a little. It's a very healthy obsession, right? Of all the things we could be obsessed with, mushrooms tend to. It's great. It's good. It's healthy. It contributes to field mycology. There's no. I mean, well, maybe my wife would say there's some negatives to it, but overall, there's very few negatives. A lot of positives.
For sure.
Yeah. Okay, so next question. Let's talk a little bit about a lot of you guys have done workshops and trainings and taught a lot of people the basics about sequencing. And so I'm assuming that you've also seen the people who kind of go for the weekend, they get a taste and they go, thank you very much, and then that you never hear from them again. And then you have the other people who kind of get into it. Is there a personality trait that you guys see, or is there a type of person that you think really fits in well with sequencing, or can it really just be absolutely anybody?
Yeah, I would say that really anybody could do it, but it require a certain personality trait. Probably a little bit of OCD, like Damon was talking about in a certain context. Just because it is often quite tedious work. It involves precision movements, and that kind of thing's just not for everybody. Especially if you're working with something like Nanopore, we're doing 1,000 specimens for a given run, and so you're having to sit there and multi-channel between two small little tubes back and forth, hundreds of times essentially. Right. And so to me it's almost like a meditation. When I'm working in the lab, the time just goes by really quick. I'm, just kind of, into the moment, essentially. And that's almost how I look at it internally.
All right. Anybody else? Qualities, traits?
Yeah, for sure. You have to be a bit of a masochist. Getting started for me, I had no experience doing lab work. It was very easy when Alan was holding my hand, but when he went off, I went through a 3-month period where I couldn't get basic PCR to work. And PCR, for those who are uninitiated, actually stands for pipette, cry, repeat, because it is it is famous for knocking people down. And I think having a cooking background, I was pretty used to being challenged by my work, and I think coming from a cooking background gives you a little bit of a leg up because you're used to following recipes and protocols. The big difference between cooking and lab work is that you can't taste everything halfway through and make sure that there's enough of this or that.
Right.
So that's sort of like throwing caution in the wind, and you set up PCR and you won't know the results. The final results you won't know for a couple of days. The immediate results you won't know for a few hours. And so this really precise work where as Stephen says, you kind of just have to go into a meditation. You can't be thinking about anything else. You can't let the time bother you. You just have to go in and you devote all this time to something. And to see that it fails can ruin people. It can totally turn you off to it. So you have to have that. You have to just want to get it to work.
Yeah, it's similar in cultivation too. It's contamination is the ego killer or the vibe killer. It's similar where it tests the passion, it tests the interest for sure. You gotta have a little bit of resolve.
Yeah, I definitely see that persistence thing is usually what I find allows people to pick up sequencing to start with. A lot of people that I kind of helped get just Singer sequencing going on their own in their bathrooms, their closets, whatever. Majority of them were just very persistent people. And interestingly enough, a lot of them tend to have had a background in a profession that was used to just having obstacles, right? And then you having to kind of push through them. And then they found themselves being obsessed with biodiversity or fungi. And then this just became the tool that they wanted to have in their tool belt. So they would just keep going until it worked.
Right.
And then once you locked it in, then it was like kind of like riding a bike that just, you get a flat tire occasionally, but you've got that now as something you can just do and get stuff done. And so that's been kind of cool, like bumping into some of these folks that have been doing it for a while where they had huge hiccups to start with. And now it is this thing that where they're like, oh, I really wish I knew what this is. I'm just going to take it home and I'll get Singer done on it this week and then I'll know what it is. And it's just like,
So,
that's so cool.
Tool
to see
in
that.
the toolbox. Yep.
Yeah.
That's very cool. All right, Kyle, for you, like what, because you're obviously doing well. All these guys know who you are, and you're a good student now, turning into a player in the space. What traits do you feel like you have that has allowed you to keep going and succeed?
Oh, that's a good question. Probably my motivation. I see myself succeeding at it. So, kind of like Hart was saying, like I've had some serious fails, and you'd have to be a person that can take those fails and then just tell yourself, you know what, I'm gonna do it because it's possible. We got to, find a way, do what it takes to figure it out. Type of mentality, and then patience, and then time. You really can't be watching the time. I've stayed up countless nights till 3-4 in the morning. I have kids, so they go to bed at about 9:30, 10 o'clock, and that's when sequencing starts, and it's a long process. So definitely, you have to be patient and have time.
Gotcha. All right, so I got a question. This is more a personal question, but I think it'll be slightly beneficial for everybody. So I just geared up, and I'm, going through protocols and deciding where I'm going to get, am I going to use master mix? I'm going to mix my own. How am I going to extract this? Okay, hey, do I actually ended up buying both mini PCR 8-well and then, what is it? PTC 200. I don't even know what it is, but some old, paperweight that costs $70 but has 96 wells in it. And as I'm like reading through these manuals and all this stuff, it starts in my head. In cultivation, everybody talks about tech, right? What tech did you use for grain? What tech did you use for substrate? And I'm starting to get the sense, especially when it comes to extraction times and protocols and all this, that I'm gonna have to pick a tech and run it. And some of you guys have probably ran a lot of different machines, a lot of different techs, used a lot of different, whether it's master mix or I forget. I just bought, I think, extract an amp or X-amp or something like that. How important for a newbie is it to try everything versus just start with one set of techs or protocols and just stick with that for a while? Do you learn more by trying all sorts of stuff, or is it really more important just to get the success right away?
I could personally see it going either way. My personality, I tend to like to try a lot more things, and so that way I have a better foundational knowledge of like what's going on and how these different protocols might differ with the results from each other.
Okay.
But if you're more of a personality type that just wants to follow a recipe, it's totally fine to just pick something out there that people have reported that's working and that you should have success with relatively quickly. And so, if you're really wanting to understand the fundamentals of what's going on, I would totally suggest most people. So, like with extraction solutions, as an example, there's, probably hundreds of different extraction methods out there you can choose from, and there's a lot of kits from companies. There's home brew mixes, and trying a little bit of everything over the course of time. Especially, with my cultivation experience in the past, I'd try all the techs, to see what worked best in my environment. And so I could see it going either way.
Yeah, it depends on what type of risk you want to take on, I think, is what it comes down to big time. Sorry, Hart, go ahead.
Oh, yeah, I was just going to add to what Steve was saying. And for me, a lot of my pathway was from failure, was from having Alan, give me this, follow these directions and it's going to succeed. And then something didn't work. And I didn't know what was going on. I didn't understand the process enough. I didn't know what was happening in the tubes. And so learning that is really important, and part of my learning that was just experimenting with different things. And once you start to understand what's actually going on, then you can really play around with things and try to optimize. So I think at this point, I'm going to go with whatever's going to be the least number of steps, the most simple, and even if it isn't the best, it's going to be the most efficient. So,
and build from there. I think that's actually what I tell new people who want to grow. The same thing. I say start with the simplest possible process, and then once you got that down, move on from there. Because at least that way, if something goes wrong, if you have 50 steps, it's harder to figure out than if you got 5 steps or 7 steps or something like that. So
yeah, and I would add to that, like with master mix as an example, you can always make your own master mix and it's going to be a lot cheaper, but if you buy pre-made master mix, that minimizes your other potential points of failure. And so,
Right.
you don't have to isolate those types of, systematic issues as much if you used, pre-mixed chemicals rather than mixing them at home.
right.
Yeah, and that's why it's nice to kind of be able to lean on that stuff that somebody else already makes for all the chemical stuff as much as you can. You're basically offloading the risk right onto somebody else. You're paying a little bit for it, but then that allows you to take your risk and then put it on the stuff that might be more beneficial to you, which is process changes of like manipulation, like on the extraction and things like that. And that's why I think taking a protocol that already exists, getting it where you're up and flying, and then starting to pull it apart, like Hart was talking about, is really where you're getting the best of both. Because you're going to get an end result at some point, and then you're going to learn how each one of those little steps actually influences it, and then all of a sudden your master level, because then where you can kind of push the protocol to then make it work for things that are hard to work with. And that's just kind of like process optimization, and a lot of like scientific labs ends up looking like that. Cultivators do that all the time too.
Right. Cool. Okay, so next question. Let's talk a little bit about Singer. Singer's been around for a while. It's kind of, I'm assuming where you would recommend a new person start. Maybe if you guys want to talk a little bit about what it is, how you go about. So, okay, say I figured out how to extract DNA. I know I got, I've used gel electrophoresis. I know I got a good extraction. How do I get a Sanger sequence? Just kind of talk me through that part, because that part still, I know where to go, but it also is still the intimidating part, because it's like, where is it? How do I do it? I don't live in Oakland, so I can't have that company just come and pick it up from my doorstep and all that good stuff.
The beauty is a lot of those companies now, you can just send it through the mail, which is great. So once you have that PCR product, right, and you saw it in your gel and you're like, yep, it's the right band, size, everything, literally just put it in an envelope and send it to these companies, and they'll be able to kind of produce sequence on it. As long as you're giving them the right primer in order to prime their Singer reaction with, or if you've done what I like to do, which is offload that, and I actually build in M13 sequences into the primers. And so all these sequencing companies have this sequence primer already at their place, and you just say, hey, just process it with that primer, and they can just push it right out for you. So, if you've already got your band, you've already done all the hard work at this point, and now it's just about communicating to the other folks how to take your sample and just process it so you can get data back.
So once I've extracted it, why do they have to add more primer?
Because they're going to, so with PCR, right, you've just run PCR on it, so you've got that theory under your belt. They're running something that looks very similar to PCR, except it's going to use one primer, so you're just going to read from one direction.
Okay.
And what's going to happen is they're going to mix stuff that looks just like your master mix, except that it's going to have these dye-labeled nucleotides, so one for each base. And what will happen is randomly those nucleotides with a big dye on it will get inserted instead of a regular nucleotide, and it'll cause the reaction to terminate. And so you'll basically get a fragment of a certain size come away from that primer with a nucleotide dye molecule that tells you what was there. And you'll randomly end up generating that for all of the positions coming away from that primer for over 1,000 bases. And then they just separate that out on a really fancy gel, just like your gel electrophoresis, and they read out basically the color patterns from those dyes, and that tells you your sequence.
Oh, see, I have not researched that far about how the Sanger actually works. So it's very accurate then by doing it that way.
Yeah, and the thing is, if you've understood the theory of how your band, you've understood PCR, you've understood gel electrophoresis, that's basically what on their side, but like a little slightly fancier version and a little more expensive. Wise, you've got.
All right, we lost you a little bit there, but I think what you said was it's similar to what we're doing at home, but just more robust, longer, larger, bigger set.
Yeah,
of
it's essentially just a final chemical reaction that occurs in the lab that they put on a gel and they do the reaction, then view the results on the gel and read you the results.
Yeah, you could even do the thing that they do at home. It's just the final step requires this big machine that they have to load it into, which you probably wouldn't want to try to do at home unless you had hundreds of thousands of dollars.
And service contracts and all that.
Right. And you knew you had the business.
Right.
But that's where Nanopore comes in. I'm sure we'll talk about that later.
That's where Nanopore comes in.
Yeah.
So yeah, and we're gonna. I want to talk a lot about Nanopore, but I want to make sure we get through some of the Sanger basics. So all the companies that provide Sanger sequencing. So if I send in a batch of 96 or a batch of 8 or whatever I send in, all those results I get. I'm assuming they have like online databases. I get all the results, I can download those, I can put them in my own spreadsheets, or they're already a spreadsheet, and then I can start accumulating that information and then do whatever I want with it. I can hoard it and hide it and will it to my children, or I can actually then submit it to GenBank, right?
Correct. Yeah.
Okay.
Yeah, I use MC Labs, so after I do the PCR and then check gel on Sanger, then I ship the tube. I usually do 8 at a time, sometimes 16. Ship that in an envelope, costs like $10. Gets to Oakland in like 3 days from Ohio, and then they read the result. They send an email that night, but it's usually around 12 or 1 a.m. our time. And then so I usually wake up the next morning. And you just download a zip file that has all the raw files in there, and then with the right applications and software on your computer, you open them up, view them, clean them up if you need to. And then, blast search them.
So I know $8. I think I looked the last place I looked up. I forget if it was your place or not, but yeah, $8.50, something like that. I mean, given what they're doing, it's really not that crazy. But when you're like Kyle and you want to sequence, 1,000, or if you're like Steve, you want to sequence 10,000 things or 100,000 things, obviously it gets low cost prohibitive. But really, it's pretty amazing that is available to anybody. I mean, it's kind of miraculous.
Yeah, a little over a year ago, so I primarily worked with GeneWiz when I did Sanger sequencing, and I was paying about $1.50 per read. So I typically would do a forward reaction and a reverse reaction for Sanger. So it's actually double the cost per specimen,
right?
If you're doing it that way, so it adds up even faster. But back then, GeneWiz, there's a backstory there. So they had acquired a company that had a really special rate. And the lab that I worked with at the time had that rate that was grandfathered in. And so up until about a year ago, they were continuing that program. They called it like single pass sequencing or something from GeneWiz. But I started on working with Nanopore right around the time they decided to discontinue that program. And so now I think it's something like, I don't know what you guys are paying currently, something probably more than $3 per read. And so that's at least $6 for a forward and reverse read that you need for, well, you don't need, but that's helpful for a given specimen. And so those numbers do add up quite quickly if you're working with lots of specimens.
Yeah, man, I think that $3 a read, that's like if you're buying the 96 well, where they send you the well and all that. So if you're just doing a handful, I think it's like Kyle was saying, like $8. So you were spoiled, dude.
Oh, I was spoiled for a very long time.
Yeah.
And that's actually one of the things that allowed us to make the progress that we did in Indiana over the last 5 years or so, is just having that sequencing rate that was very low relative to what most people could get.
Yeah.
Nice.
So, but that's the exciting promise of Nanopore, is we're not talking about, $8 or $3 or even $1. We're talking about cents, right?
full-in cost for extraction, amplification, and sequencing of something 30 to 40 cents per specimen, rather than paying, what, $16 per specimen for Sanger sequencing just for sequencing?
Yeah, that's
So
crazy.
it's a fundamental difference.
A little bit. Well, it puts something that's just not possible into the realm of possibility, so that's very cool. And that seems to, things like Damon talking about mapping out biodiversity, in large regions and things like that. Just on a citizen scientist level, you're just not possible. You can't run enough GoFundMe's to fund that 100,000 sequences at $3 or $8 a sequence, but at 30 cents, it gets a little bit more realistic.
And so just like a little bit of history in terms of, those kind of thought processes. So the North American Mycoflora Project, when it was first being conceptualized, I think they were wanting to estimate it might take $18 million or something on that order,
Right.
To have a nationwide program to be able to achieve a survey of all the macrofungi that exist in North America.
Right.
And so, it's only been a few years later. That would have been maybe like 2014, I want to say, is when they were putting out those kind of estimates. And so things have fundamentally changed from that perspective since that time as well.
It's like it's easier to get excited about it with this new technology, right? Instead of going, oh, this would be great, but costs too much money. It's, oh, this would be great, and it's totally doable. Yeah. All right, so let's since we've now kind of romanced Nanopore a little bit, let's talk about just the fundamental difference, both in the scale of the sequencing and just the fundamental difference of how it works.
So, yeah, I can take it briefly. Damon talked about, you have to keep in mind what part of the process we're talking about right now. So nanopore sequencing still uses DNA extraction,
Right.
and it still uses PCR for amplification. So all we're talking about is a final step that involves DNA sequencing. And DNA sequencing is just figuring out the order of the nucleotides in the genome. So the A's, G's, C's, and T's, a fungal genome has something like 50 million A's, G's, C's, and T's in it. And all sequencing means is figuring out the order of those A's, G's, C's, and T's within that genome. So that's slightly different than fungal barcoding, which you've also talked about a little bit. So barcoding is only looking at something, 600 A's, G's,
Right.
C's, and T's within that longer entire genome. And so most of what I'm doing, and most people here primarily work with, is DNA barcoding,
Right.
which is a form of sequencing, but it's working with a much smaller fragment, and it's primarily used for identification of an organism.
Nice.
And so Sanger sequencing, Damon mentioned, uses a process essentially similar to gel electrophoresis to make a determination of the order of those A's, G's, C's, and T's. Nanopore uses these little tiny, and I should probably grab one here in a second, but these little tiny things called flow cells that have a bunch of little biological pores in them, just big enough for a DNA molecule to run through. And a given flow cell might have, I think the smaller ones have about 120 little pores, and the DNA is guided through those pores. And then the computer software and the equipment looks at changes in electrical signals as the different bases go through the pore. And so from there, it's essentially just using a computer software, a computer algorithm, to turn all of those changes in electrical signals that it's reading from all of these pores into the A's, G's, C's, and T's.
So actually how it gets the read is quite different.
Absolutely.
Now, I think, oh, sorry, go Hart.
Oh yeah, I was going to say. Well, I mean, one of the major differences is that you're directly sequencing the DNA, and that gives you a lot more flexibility. So with Sanger sequencing, the maximum size piece of DNA that you can read is going to be maybe 1,000, 1,500 if you're lucky base pairs long, just because of the way the technology works. With nanopore sequencing, you can read up to, I think the longest read at this point is like 4 million base pairs. So you can
more.
read these really long stretches of DNA, and you don't necessarily need to do PCR before you do nanopore sequencing. You don't need to make many copies of this DNA, and this is the one unique thing about this technology when compared to Illumina sequencing, Sanger sequencing. You're directly reading the DNA molecule, so you can sequence an entire genome with Nanopore. You can sequence what we're doing is fungal barcoding, so you can take the PCR, the amplified DNA, and sequence that. But even further, because you're directly reading DNA, let's say we're not doing PCR, we're not doing barcoding, we're just looking at the whole genome. You extract the DNA from a mushroom, you don't amplify it, you don't do anything to it, you just put it into the nanopore sequencer. You're detecting these really minute electrical signals as this DNA is going through the pore.
Right.
There's a whole field called epigenetics, which focuses on not just the A's, C's, T's, and G's, but things called modifications to those bases.
Right.
So it's deeper than just the 4-letter alphabet. We've got things called methylations, where you actually add methyl groups onto one of the DNA letters, and that can change gene expression. You can actually pick that up directly using nanopore sequencing. Whereas if you're using something like Sanger or Illumina sequencing, because you're making a copy of that DNA first, that information is lost during the copying process. Right. So, just want to clarify, that's sort of an additional dimension to doing this, which makes it all that much more powerful.
Interesting.
And especially if you're looking at doing like whole genome stuff, the Nanopore and some of these other like long read sequencers is where it's going to allow us to start looking at whole genomes quicker, because it's going to be a lot less effort to kind of put the puzzle back together of all these sequences to then build up a full genome. Because like on the old Sanger stuff, so this is actually an old Sanger array right here. So this is similar to your gel electrophoresis gel that you're running, just each one of these is one of those wells. It has the same limit as a gel, where at some size, those fragments just can't migrate, so you can only read, maybe 1,000 bases if you're lucky. But like Hart said, with Nanopore, I mean, you can get up to these extremely large reads, which then allow you to see a lot more of the genome, which means if you're trying to sequence the whole thing, it's going to be a lot easier to kind of put this thing back together from a bioinformatics point of view. And that could even be helpful, I think, down the road with DNA barcoding, because most of us have been using ITS for years, but it doesn't always resolve all groups of fungi. And so being able to look at larger chunks of the genome will be helpful, or just being able to capture a couple kind of barcode regions all at once.
And so my understanding of it, I think Steve, you did a post one time talking about this a little bit. So right now, this the electrical analysis of what happens when it moves through this, I guess they use really small drill bits to make all these holes. Is that right? No, I'm kidding.
More or less.
Yeah, it's a really small drill bit. It's like a Makita. I think they use Makita drill bits. What I thought was really fascinating, you said in a post one time, was that right now they're using like certain software, certain algorithms, certain ways they're interpreting these electrical changes. As time goes on, that's going to get more sophisticated, more robust, more dependable, so that you will have the data from that read that, say, you do tomorrow. And if in 10 years there's the most amazing Windows upgrade, so to speak, for the software, you have that data and it can be reinterpreted by the software, which is completely different than how Sanger works. When you run Sanger, it's done. And your sample is not going to last 10 years from that particular sample. So it's fascinating. When I read that, I thought, this is amazing. If somebody like Kyle does find a novel species and he nanopores it, I mean, maybe he does both. Maybe he, does ITS at first and says, oh, this looks like this might be something new. And then he nanopores it. He will have that nanopore read in perpetuity that can be potentially more sophisticatedly rendered in the future. I mean, that's really cool.
Yeah, I would say that's something to keep in mind with Nanopore broadly, is that much of the technology, particularly on the informatics side, so particularly the analytical side that uses computers to do all of that processing, is still very much in its infancy. I would say most of the different aspects of the bioinformatics which is all the post-processing analysis, most of that really does still have a long way to go, and there's a lot of opportunity for skilled data scientists to make a pretty big impact in the overall results that are possible with Nanopore.
Right. Now, so I remember I have at one point in time seen a post where you're defending, it's basically the success, I forget if it was the success rate or if it was the accuracy rate, Nanopore versus Sanger. I'm sure, it's much like in the cubensis community, there's some guys from the shroomery who show up on Facebook and they just start crapping on everybody. And it seemed like there was a little bit of drama going on there. And I think of this because you just mentioned that everything is still in its infancy. You're actually playing a very significant role in developing this, the protocols and whatnot. I remember looking up a protocol just for Sanger and just accidentally seeing one of your Nanopore or one of your MinION protocols, and I thought that was just cool to be like, oh wow, like this is all just getting figured out still right now. Maybe talk a little bit about the pros and cons, the struggles. I also remember the term fungal. Am I saying a correct word?
Yep.
That you guys bought an expensive fungal and you got a bad fungal, and I'm just, of course, cracking up over here like, these guys are talking about fungals. What the hell is a fungal? But that is a even though it's much cheaper, I have seen posts where you're saying, well, I did a whole run and nothing worked. So maybe talk about some of the hiccups, some of the specifics about how it works that's been challenging for you and for Hart, and Kyle's about to have the same struggles, I'm sure.
Yeah, so I would say for the very last point, with the flow cells that we mentioned, that actually have all of the pores that do the actual reading of the DNA, one of the challenges is they seem to be, so Oxford Nanopore just recently put out a new version, their 10.4 version, and I'd previously been using their 9.4 version, I believe. And the newer model tends to have a higher pore failure rate. And so, these things have to be kept at a certain temperature. They're actually shipped to you, and during that shipping time, they have to be kept at a certain temperature under the right parameters, so that way the pores don't go bad. And the newer ones do tend to have a higher pore failure rate for me. So I often have to use 2 of the individual cells to get a full run. I haven't had one run that's just completely blanked with nothing. The problem is typically there's just a low pore count that's available for sequencing. And so, but you can rectify that by just using the same DNA that you just used and sequencing it again on a new cell. I briefly comment on the other aspect that you raised too, which is accuracy. And so there is some discussion still about the accuracy of Nanopore. And I would say that we talked about DNA barcoding versus whole genome. So like looking at, an entire genome, potentially millions of reads at once, millions of bases at once versus the 600 bases that are in DNA barcoding. For how it actually works with Nanopore is if you're trying to get DNA barcodes, you're actually going to get hundreds or thousands of individual reads coming out of the technology. So your DNA is amplified. There's potentially millions of copies maybe within your DNA sample that you're using. And so you're going to actually have thousands and thousands of individual reads that come out in the results. With Sanger sequencing, you just get one single trace file. So one single file that has the raw data output. With Nanopore, you're getting, in total for a run, you're probably looking at, a million or more reads coming. And that's why it's really important to have a really good analytical pipeline in place to be able to make sense of all of this data that's coming out. In terms of accuracy, Nanopore, I would say, even with their latest version, still does not have great accuracy for an individual read. So if I was doing a whole genome, I probably wouldn't be looking towards Nanopore as my primary technology for it, because it's just not going to be accurate enough. I would say the same thing is probably true if you're looking at like environmental DNA. So you can actually, extract DNA from the soil in an environment and look at all the DNA that exists in the soil and identify the mushrooms that are likely to be there, even without seeing the fruit body. And so for that kind of effort as well, I would say Nanopore is still probably not accurate enough to utilize for that specific purpose. But with DNA barcoding, you have lots of replicates of one individual known sequence, essentially. And so you're essentially relying on a process called consensus building, which is compiling those thousands of reads from that specimen into one single final sequence. You're using that as a error as a way to correct errors within the technology itself.
Right.
And so for something like Illumina, you don't rely on consensus building in order to provide error correction. But with Nanopore, you actually are relying on your consensus building to reduce that error rate. And if you have a certain number of reads, I typically say if you can get 100 reads from an individual specimen coming from your output, it's going to be of Sanger quality.
Yeah, so that makes me think, like, has any statistician actually figured out, because you're saying in Nanopore you might get 100, 200 potentially slightly incomplete reads, but then it can be sort of the consensus of what that actual read is can be built up. Like, I feel like you could almost, in some cases, be more certain about the read, because still Sanger still has an occasional, missed nucleotide, right? Like, it's also not necessarily perfect. That's why you guys run them forward and reverse. But in that case, like, is there a situation where potentially that's a more robust, or not robust, but a more is there like greater
solution?
Confidence? In that?
I would say without question, people have more confidence with the Sanger sequencing just because it's been the gold standard since maybe the 1980s or something like that. But even with Sanger, you're still having to manually edit most of the results that you're getting, and so there's still a lot of subjectivity in terms of the interpretation of that. And you also have a lot of things that have been placed in the gen bank that I would say are not up to high quality, even with Sanger sequencing. And so there's still plenty of room for potential failure, and so it really comes down to what methodology are you using, what protocols are you using, as to whether it's going to be, there's going to be comparable accuracy between the two.
Right. Now, I think you said something one time in the Facebook group about that. So with Sanger, right, if you got some other molecular contamination, it could screw the read up. Whereas with Nanopore, it's like you can just dump DNA soup in there and it's going to read everything, and it's more up to the software to decide, whether it's got some quality information or not. Do you want to talk a little bit about that? Because you just said it's not really great yet for like soil science, like pulling soil DNA and then trying to figure out what's in there just because of accuracy. But I feel like that's kind of a cool feature of it, that it doesn't have to be as pure of a sample, right?
Yeah, so take something like a bolete with a bolete mold on it, like a hypomyces. If you were to try to do an extraction and then run Sanger sequencing, and you have both the contaminant as well as the target in the same reaction with Sanger, you're going to get a final trace file, the raw Sanger output, that's maybe has double peaks or that's maybe muddled all throughout it. And you can't make heads or tails of what that final result is. But with Nanopore, you're essentially left with a bucket that has two independent sequences in it, one for the mold and one for the target. And so that's definitely an advantage. Many things that might otherwise fail with Sanger sequencing can quite often work with Nanopore sequencing.
Nice.
To speak to some of the accuracy and to echo sort of what Stephen was saying about whole genomes, one of the things I'm working on with Nanopore is actually doing whole genome sequencing for the Entheogen Genome Project. We just did 6 genomes using Nanopore, and it's not accurate enough in most cases. You have to use the same sort of consensus building where you're looking at least 100 times coverage. So if the fungal genome is 50 million base pairs, you have to get 5 billion reads to do enough coverage of that to be able to build a consensus on the genome. Now, there's kind of a bit of nuance to this, and this is something that I still have some lingering desire, and this can all be fixed on the data pipeline. So ITS has about 100 copies in fungi, and an individual mushroom will have about 100 copies of the ITS region, the thing that we're using for barcoding. And it's not always so clean and neat in that all of those copies are the same. Sometimes you have significant variation, up to 3% within that. And neither Sanger sequencing nor Nanopore is necessarily powerful enough to separate that into different buckets, so to say. But when you do Sanger sequencing on something, you get an average of those two sequences, and you can sometimes use that average to separate them out. When you do Nanopore, currently the way that the pipeline works is it builds a consensus. So it's not smart enough to see that there is two different ITS sequences in the same mushroom. It's gonna decide that there's an error, and it's gonna combine them into one, and it's gonna choose one over the other. Is that important for the work that all of us are doing? Not necessarily. Is it something that should be made better? Definitely. So so there's still some nuance. Is it still better than Sanger sequencing in the sense that it's an order of magnitude cheaper? You can do an order of magnitude more at the same time, and functional accuracy is just as good, because does it for the sake of discovering different species, it's not gonna matter so much that you have this variation within the entire ITS. With most genera. Now, if you're looking at things like Gymnopilus, certain species of Psilocybe, where these so-called ambiguous positions or polymorphic positions, where there's differences between the two ITS, that can be a little bit more informative. So there is a use case for why we need to improve accuracy in Nanopore, and this is something that it can be done because it's just a software fix.
Right.
So, yeah, I would just echo one more thing on that point. His last point in particular, the only reason, and so I refer to the problem that he's talking about as haplotype conflation. So when you're building a consensus sequence, it essentially just tries to meld everything together into one bucket that could otherwise be separated. Right. And I would say you can actually look at the raw data and look at it manually. You can build an alignment of the raw data, and the data is there to be able to separate them. The only problem is the bioinformatics, the software that we utilize for that. The program I use for consensus building right now, I think was designed in the early 2000s, before next generation sequencing was even a thing. Right. And so that's what I mean by the data scientists still have a long way to go to catch up. The bioinformatics have not caught up to the technology to this point.
Yeah. That's a good point. You can manually align things and pull those out if you really want to get that depth. So it's no improvement needed on the sequencing side.
So you guys were talking about millions, right. So, okay, I was today years old when I actually specifically knew sequencing is for the whole genome and barcoding is for parts. I guess I've been conflating those two words. But I'm sitting here thinking, and one really cool thing about Nanopore here is that it can do really just infinitely much larger runs, right? As long as I'm assuming that DNA strand holds up, it can, and it runs through my Makita drill holes. It's gonna pick up this electrical variation as the little nucleotides go through it. None of the others are doing that, so it just seems like that's more exciting. And now, Damon, you can maybe talk about this. I also used to think that when we say the DNA, right, our DNA, the whole genome, this kind of thing, I just imagined it was just this one string, right? It's just this one thing. I didn't realize, oh, there's mitochondrial DNA, and right, like it isn't necessarily just one string that exists everywhere in every cell all the time, that some cells might not have all of the human genome and all this kind of stuff. But that's really exciting to be able to capture such long strings, and I imagine as time goes on, the dependability of these filtration cells are going to get better, and the way they're prepped is going to get better. I have to assume that some really exciting things that are not happening with the other sequencing methodologies make this really cool. And it's freaking portable.
Yeah, I think that's the big thing.
That's crazy.
It's portable and it's like financially accessible, because there's been a lot of other sequencing technologies between Sanger and Nanopore, but they just haven't been financially accessible because the equipment's really expensive. So there's no way you're going to buy an Illumina machine, or at least one of the old school Illumina machines, and have it in your house, or a Pack Bio machine, or an ABI Solid, which would have been a horrible buy for a whole bunch of reasons. And so that's the really cool thing about this. But I think also, like going back to what Steven said, is the beauty is you're getting individual looks at individual strands going through your pore, which means you can bin them. The bioinformatics isn't there to do that, but the fact that you could bin them allows us at some point to look at some of these polymorphic problems that like Hart is talking about, where you couldn't do that with Sanger because all of those pieces are all moving together and you're just getting a high-level view of a population, where here you could dig into the individual reads, individual strands, and bin them out, which is a really big difference and a big benefit. I think that's one of the biggest upsides too of Oxford Nanopore. Just people learning how to then work with that sequence is going to be the thing. And just like other technologies as they came online, we saw this with Oxford, because they came out in, I want to say like 2013 is the first time I heard like the rumblings that they were coming out. I worked with the technology in 2014 on a Tuatara mitochondrial genome, and everybody was just upset because they're like, oh, the error rate's too high for you guys to work with. But then if you do the consensus building, you could get away from that. And their technology has been getting better slowly, like every year, right? And so I feel like we will see this technology continue to mature for quite a while. And I don't see another huge technology jump as far as sequencing technologies go on the horizon right now. I mean, some people have talked about AFM stuff, but I think Nanopore is going to be here for a pretty long haul compared to a lot of the other sequencing platforms that have come between like human genome and now.
So for, instead of barcoding, right, everybody wants to sequence everything because that's where the money's at, right? That's where you can find something, do something with it. So you're kind of saying this really is the ticket, right? Like you worked on the Human Genome Project. You guys were not running 15 or 3 million base pair strings, right? You guys had to slap it all together really, really slowly over a long period of time, right?
When we were all doing that like in 20 to 100x on these old ABI machines.
Yeah.
The beauty is here is just the pipeline is so much bigger. The data, I think, if you learn how to use it from a bioinformatics point of view, is actually going to be better to work with than Sanger, because you're getting looks at single strands, and there's a big benefit to that. I think first it comes out really easy with the barcoding, like Steven said, because if you're looking at the same population 100 times, and you can see each strand, you can get some really good confidence building that gets rid of any sort of error considerations with looking at a single strand compared to like Sanger's population view. So I think just this is going to open up. It is already opening up a lot of things. But then what you will see, at least from a whole genome point of view, is the combination of this platform with other large sequencing platforms like Illumina, where you can get kind of a little bit of like error cancellation going out between the two of them if you're trying to put together a whole genome. Right. But from a barcoding point of view, like I don't see any reason why Nanopore just doesn't take everything over, like in the next 5 years.
Again, right there in the field, doing the work. That's crazy to me. It's just, what'd you do in the woods today? Oh, you built a fort? Oh, what'd you do, Steve? Oh, I sequenced 3,000 mushrooms. Oh, okay. I did nothing. It's cool.
That's the beauty of it.
That's really cool. So now I know, Steve, you, I mean, when you call customer service over at Oxford Nanopore, I mean, they know your number at this point, right?
Yeah, I've had to do a number of returns, as I've talked about, with some of the latest flow cells. But, I mean, they've always been really easy to deal with, and they do replacements. So I talked about sometimes the flow cell might arrive and not have enough active pores to do a whole sequencing run. And they have a warranty level that if they arrive and you test them and they're under a certain level, they'll replace them for free. And the last time they even sent me two free flow cells. So they have a really good customer service.
Oh, so there is a process for testing that the good pores.
Yeah, that's the first thing you do whenever you put a flow cell into the device is run a flow cell check. And it tells you how many pores are active for sequencing.
What is it? What is that? You said it's like a biomaterial. What is the cell made out of?
I can't speak too heavily on that. I believe it's I'm not sure even if it's from a specific type of organism that, what the pore actually comes from.
Interesting. That's the secret.
But I do think it's biologically based, but I'm not sure from what.
I mean, at the size the hole is, I don't know, how else do you make the hole? That was my drill joke. Right?
Yeah,
like
I mean,
it almost has to be a polymer or something, some organic polymer.
I would assume it's proprietary information for Oxford Nanopore, and that's why I don't know it. But
right, that'd probably be why.
Yeah.
But now, have you just directly asked him? Yes, Steve. That's what.
No.
Okay. I'll call him tomorrow. I'm getting to the bottom of this. Just tell me.
Dig through their patents online.
Yeah. There you go.
And you can get some hand waving around what it is. It's
Yep.
Yeah. So what? So if it's all on the bioinformatics, if it's all on the kind of software side of things, do you guys know about people? Like, how do we get the people to do the work necessary to improve this? Like you were saying, like the bioinformatics software you're using is from 2002. So.
Yeah, it's the early
What do you
2000s, and I think there just aren't enough people that are barcoding at scale to make it to have the kind of community surrounding it yet.
Right.
For this specific problem to have a solution. So to really the consensus building algorithm I utilize, it really requires a lot of, it would require a lot of people using it for there to be to someone to really be advancing it. And I think as the technology continues to progress and expand, there'll be more people that are interested in the specific some of the specific questions we've talked about today in terms of how it could be improved.
Right. So now,
if there's, I would just say, if there's any data scientists in your audience with a little bit extra time, I have a plan in my mind, and I've talked about it with several people on what needs to be done. It would essentially be, I'm not going to get into it, but I have a plan that we could operationalize if there's somebody that's into that sort of thing.
I actually think I have somebody in my Discord. I'll talk to him tomorrow. We'll see. I don't know if he's got the free time for it, but he might know somebody. Well, we already got 3. We got Steve, Hart, and Kyle all have them. So besides mushroom people, I mean, are other biologists also seeing the appeal here? So is there like a Stephen Russell of lizards and a Stephen Russell of tarantulas? You know what I mean? Like, how is the company doing? How many of these things are they selling? Because you're saying what really seems to be necessary next is that more people using this product to sort of drive the software development.
I mean, there definitely is. There's one guy that I follow on Instagram, Zane, I'm gonna butcher his last name, Libicki, who's doing this down in the Amazon, and he's a herp person, so you see him doing it on a bunch of different herps down there. And I mean, when I first got really excited about Oxford was I saw UC Berkeley started running a summer course down the Amazon. I think it was Aaron Paulimus at the time was running it, and they were doing Oxford Nanopore like in the field. You still had like a little like jungle hut lab because you still have to do your library prep, but the fact that you're just doing it out there, right, and you're not having to like come in to the city per se to do it, you can get your little lab system set up. I mean, like what Kyle's got in the background right there, right? If you can put that together in a room in the jungle, like you can get most of what you need in order to then produce sequence in the field, which is just really exciting.
The jungles of southern Ohio, Kyle.
Yeah, that'd be. Yeah.
You just got to put all that in a van, man.
Yes.
Yeah, for sure. That's why I bought the van for real, not just to haul the kids around. It was because I'm going to be mobile DNA sequencing across, the East Coast at least. So, but yeah, everything that I have, can pack into a little tote and throw into the car, or the van.
You just got to get up at 11,000 feet in the Andes and with your van and just sequence everything right there.
Yeah.
Done. Paper, published, dropped. There you go. Ready to go.
All the work right in there. Type it up.
Yep.
Well, that also kind of presents another interesting thing, and Hart kind of spoke to this earlier, is I feel like the amount of sequence coming out of even just the community science group that you see here and across the U.S. is so much that we don't have enough people actually writing the papers to describe them, the new kind of species that you're getting, like the tip of the iceberg when you get that sequence back. And that creates a whole nother pool of people that we need out there.
Right. Ed talks about that all the time. He's like, yeah, man, you could literally write papers all day just using GenBank data. You'd never have to get any of your own data. If you knew what you were doing, it's all right there to, figure stuff out. It's true. It's like you need data mining scientists to come do some of this work.
But you also need to combine that with some people that I think could actually touch the specimen, smell it, taste it, stuff like that, hopefully.
That would be nice. Yes.
Right.
Yeah, I would just say on that point that I've kind of... So there was always the concept of generating mycofloras, and that would essentially be full descriptions and names for everything that exists. And I've kind of moved past that for any of my personal goals, even for Indiana. I'm not really at this point looking to create a mycoflora of Indiana. I refer to it more as an outline of fungal diversity. And so, even if these things don't have a name, a published scientific name, I'm still able to take all the specimens of a given species and put them into a buckets and put a temporary code on them, something like Russula species Indiana 126, right? And so I'm able to know the morphology, the range in morphology, the range of the species, its seasonality, phenology. I know everything there is to know about the species. I just don't have a name for it, and I slap something Russula species Indiana 126 on it. And to me, from my goals currently anyway, that's probably where it's going to stay for the rest of my life until there's someone like Damon was talking about that might have an interest in this particular species. That would have an interest because we have all the specimens for it. We have all the color images. We know literally we could do a full description of the species, but that's just not where my interest lies. Sitting there, in front of a keyboard and typing up all these descriptions when there's so much else out there to discover still.
And it brings up a bigger question, which is is there value to having those scientific names, or is the bin all you need, right? Because if we can say at least, hey, I know what this is, and it has a bin name or scientific name, does that allow you to move on to the next thing, which is talking about what are they doing in the environment, who are they associating with, things like that. And scientific name doesn't really necessarily need to be there for you to do that, right? It's just that's what people are so used to doing for a long period of time because that's the way taxonomy is operated. But that's also when I feel like we weren't aware of how many freaking things there are everywhere. It is a lot easier just to throw them in bins and then move on to the next big question. So I think that's also a bigger question for kind of taxonomy as a whole that the genomic world is definitely bringing up really, really fast.
Yeah,
I would just say philosophically, I've moved past in my mind the need for scientific names. I just don't even think of things in terms of scientific names anymore, just because most of the things that we think we know are groups of species, and they're all going to need to be redescribed at some point. I would say literally the majority of things in every field guide that you've ever seen are going to need to be renamed.
Yeah.
Interesting.
And I actually kind of like the bin idea a little bit more, just because it also, to some degree, it even kind of helps people, I think about things on a spectrum instead of having these really kind of esoteric, oh, but that is not this or that, because a lot of these things, you think about a population and they're not all the same, right, within the bin, within the species. It's a little bit expansive, and then there's, the gap before you get to the next kind of evolutionary node. And I think to some degree, sometimes the Latin names kind of get in the way of that, or the way that we've been thinking about them historically.
It does affect how you think about it, for sure. You
Yeah,
think
one other
this
comment
is a distinct thing.
Yeah, one other comment I would make along these lines is once you start looking, for a lot of our species in Indiana, we have dozens of representatives that have been sequenced that we've been able to put into these bins. And, we see a lot of the names that might have been applied, like in a field guide or something, are actually conflations of multiple species. And that would actually be true for a lot of stuff in the past scientific literature. So even not even talking about field guides, right? If you go back into the scientific literature, a lot of the descriptions are conflations of multiple species, to where once you look at the DNA and you put them into these two bins, you can see clear, distinct morphological features that separate them, but they've always just been combined in the past because everyone thought it was a single thing. But now once you put them into bins, you can see that range of morphological variation and actually start to see things that can help you to separate them maybe 80% of the time correctly in the field.
And, well, beyond all of that too, there's going to be an inflection point soon when actually investigating the entire genome content of these organisms is going to be cheap enough, and there'll be the analysis that's going to be powerful enough to just do that. So there'll be a point at which barcoding will have a use case, but mostly for zoomed out level. But we'll actually be able to start looking at the entire content of these organisms. Instead of just a 700 base pair long barcode, we'll look at all 50 million. And already the things that are being published right now shows considerable overlap, considerable blurred lines. So just even, using the predefined concept of a species is something that's going to have to dissolve. And we're going to have to basically define things by their function as opposed to their to how we want to describe them. Trying to understand the ecology of a mushroom by looking at the mushroom itself is foolhardy. The mushroom is just the reproductive structure of this incredibly complex organism that lives in the soil, surrounded by tens of thousands of other organisms that we can't see and have no idea how to identify. And we're not going to be able to really determine these ecological relationships until we can see the whole picture. And probably the best that we're going to get is to be able to look at the whole genomes of these things, because you can't really do controlled experiments in soil. You can't say, we're just going to mix these 10 things together when in a gram of soil there's 10,000 different species. And we're lucky when we're looking at macrofungi of actual mushrooms, because there's only a fraction of a percentage of all the fungal species are things that you can see. Many orders of magnitude more species, if you want to call them individual species, are things that you can't see that just float around in the soil. And they probably swap genes and share genes all the time, so it's really complicated.
Building on that, just one additional comment. I've already, just philosophically in my mind, I don't even think about the term species as applying to macrofungi. The only reason I use it is because that's what's people are commonly use and are comfortable with. But just philosophically, I think about it more of like a network map of gene flow as to how species should probably be best defined long term.
For fungi,
Yes.
not for mountain lions.
Well,
There's a case to be made for both, I think.
Okay.
Yeah.
But
well, it's interesting too, because I think we'll see this. I think the bacteria and the archaea folks are already starting to see this as they've got smaller genomes, right? And so we're seeing a lot more of this whole genome comparison going on there. And I've seen and talked to a lot of folks that are kind of feeling the same way Stephen does about this, which is thinking about them as like nodes or population dynamics, right? And then I think we'll just see that roll out into more and more complex genomes as we're able to sequence more and more of them. That they're these continuations, not just dead end like here's the species. And so I think fungi are the next ones up, just because of genome size to some degree, and I think interest right now, because at least from the biotech side of it, like people are realizing, geez, there's all of these free tools out there that are in this kind of kingdom or domain, however you want to think about it, that we'd love to mine, which is going to mean a lot more of these full genomes will hopefully start coming through the pipeline.
soon.
Soon.
And there's a lot of them. And only Nanopore can save us.
So
right?
one of the reasons why we don't do full genomes right now, or at least why I'm not interested in them, is essentially what Hart mentioned a minute ago, is that you have to have such a high level of coverage for each individual region to be able to generate that consensus. What that means, just in practical terms, is that it's more costly. So my primary goal, and so it all depends on what your goals are in terms of your research as to what path to take, but my primary goal is understanding what's in nature. And for most species of macrofungi, the ITS region is wholly sufficient to make a species delimitation, and so, or an identification. And so that's what my primary interest is. And the longer the fragment that I sequence, the fewer the number of specimens I can put on an individual flow cell, which means that it just costs more per specimen if you're trying to do these longer fragments.
Right. So now, how much of your legwork, this is first probably directed to Steve, but the other guys, if you guys have something to say, please say it. You were saying you don't even have to use primers, you don't even have to amplify anything. Really, what do you mean by that? But I have to imagine you are still trying to extract DNA, you are still trying to do amplification. So, but I feel like you said that almost as like a tease of what could be in the future for how sophisticated that technology could evolve, that it could just get crazy simple to do this.
So longer term, I would say that's probably where we'll end up, is not amplifying things and just kind of almost continuously sequencing as much DNA as we can extract from the environment. So the problem is when you're looking at if your goal is the identification or delimitation of species, you have to compare it to something else, other DNA that's already been sequenced with a name on it. So we refer to that as reference data. And if you're just kind of randomly looking at all the DNA of a specific organism and sequencing it that way, the odds of having reference data for whatever segment you're looking at is much decreased. And so you have to sequence a whole lot more bases, which means a whole lot more cost. So it would totally be possible for everything I'm interested in to just do an extraction and send the raw DNA through the nanopore, but then it almost becomes like a needle in the haystack type situation, to where whether or not I can get a good sequence at a high enough resolution. Remember, it has to be potentially 100x for a given region for it to have high confidence or at least Sanger level accuracy. And so that it just becomes a much more expensive proposition, but that's sure to change over the course of time.
Man, so you got me sitting here thinking. So the first thing when you were talking about binning sequences, I was thinking, so I just imagined, let's say I could take somehow magically every fungal, unique, finite set of DNA that existed in, I don't know, Northeast Ohio. And I could somehow use a magical nanopore sequencer that just sequenced it all, so I could just all of a sudden have sequences of tens, if not hundreds of thousands of fungi. And I could input all that data into like a Mega 11 or something like that, and it could create this massive phylogeny tree for all this information. Then I can start seeing how things are related. So as you were talking about, like, species don't matter, or it's going to matter less and less because you get this bigger picture that you never were able to get before. You couldn't truly molecularly see how things fit together and how they were similar or dissimilar and where the similarities came in and left and all that kind of stuff. But at the end of the day, I'm sitting back going, but I mean, like, for people, the way we figure out species for a long time has been kind of, to a greater or lesser degree, do they maintain populations? Do they reproduce? Do the offspring, biological species concept, basically. How does changing that thought of thinking that way, that paradigm, and you shift it into a very it's like we're going non-binary here, guys. We're like today it was this, tomorrow it's this. It can evolve. What impact does that? And I'm not saying that isn't potentially true, but that might be a level of sophistication that I don't know if like an actual human being's brain ever really can wrap around. We now have computers so robust that the computers understand it. But can we ever really understand that, and how does that affect how we teach biology, how we understand our world? Like, do you know what I'm saying by this?
Yeah, for sure. So we do have this concept, and it's actually been pretty well ingrained. If you study bacteria, this is just common knowledge that bacteria fall into categories of species that are defined by what's called a core genome. And that is the thing that is the most basic unit of this organism. But depending on their habitat and the things that they interact with, they can pick up genomic content and lose genomic content. It's just like for folks that grow cubes, right? You've got your cubes that have, that turn into these like lumps, that lose the ability to develop spores. But it's even more complicated than that. Right. So if you want to apply this concept like we do with bacteria, so E. coli that lives in your stomach, totally fine for you. E. coli that lives in a cow's stomach, you put that into you, E. coli 0157, well, it produces this toxin that can kill you. You look at this concept applied to macrofungi. A paper recently came out describing porcini as being this collection of 6 different populations that we can all call Boletus edulis. But the actual similarity between 2 of these populations on a genome content level, like the actual functional genes within them, can be 60% different from one to the other. So they might look the same, they might have a similar ecological role, but because the specific ecology is so different. So porcini that we used to call Boletus rubriceps in Colorado, and we can still call it rubriceps. We don't have to go by what the paper says. Associates with specific trees in a specific soil type in that environment. Boletus edulis var. Grand edulis here in California that grows on the coast and in the mountains looks very similar, has a very similar ecological role, but there are different organisms that it's interacting with. You actually look at the content of the genome in places where you have thick duff, for example. You will see more genes that are able to eat the duff, that are saprotrophic genes. In a place that doesn't have much of that material, the fungus has to rely more on the plant for nutrition. So it can't eat the surrounding detritus to feed itself. It has to get it from the plant. And you actually look at the genes within those fungi, the ones that are living in that environment where they can eat the detritus have the genes, and the ones that living in an environment where they don't have the detritus have lost those genes.
Yeah, they use it or lose it, right? I guess.
It's more so. You're not doing away with the idea of species. You're just looking at it from a different perspective. You're not like, oh, well, this one has a red cap and the spores are this size, because that doesn't tell you anything about the organism itself. You're looking at it more so, what does it do? And then you can start to assign, you can say, this is Boletus edulis, Grand edulis if you want. You can retain that concept of species, but more accurately, you're going to have to start putting codes on things. You're going to have to say, well, this is the strain of Boletus edulis that associates with these trees in California, and this is the strain of Boletus edulis that associates with these trees in Colorado.
Right. I mean, so here's my question. How is that different from, I mean, you can tell my ancestors didn't get a lot of sun, right? So I'm like a super white guy. But I'm a Homo sapien, and so a woman from Tijuana who is 4'11" and from an Aztec descent, she looks radically different from me. but we can hook up and make another Homo sapien, right? So we're, like you're saying, we're very differentiated in our expression of our genes, but our genes are still very compatible. How important is it then to differentiate that, right? So something can look the same, but can it mate? Or something,
Yeah, well,
do you know what I mean?
Yeah, for sure. I mean, in the case of humans, we have virtually identical genome content. So, you're going to have the same genes, same functional genes that someone who looks different does.
Right.
They may be expressed at different levels, leading to a different phenotype. But what I'm referring to is actual whole chunks. 60% of the entire genome is different between these two organisms.
But to our observational eye, it looks the same.
But it looks the same to the observational eye. So it's kind of the opposite. It's like you might look different than this person, but your genes are the same. In this case, they keep this core concept of what a porcini is. But again, when you're looking at the porcini mushroom sticking out of the ground, you're just looking at the very ephemeral reproductive structure. It's like looking at a flower and trying to understand the ecology of the entire plant. Well, a magnolia tree can have a flower, or this tiny little thing in the ground can have a flower. If you're just looking at the flower, there's no way to tell the difference.
Right. But so now here's my question, right? So in the basidiocarp, we have the two nuclei, right? It's dikaryotic in nature. In the ground, the mycelium is mostly dikaryotic, but maybe there's regions that only have one nuclei. So why does it matter as much? I mean, I agree with you that it is only the fruiting body, but when we're sequencing it or we're barcoding it, why does it matter to differentiate that it's only the fruiting body? It still contains all that essential information, right? Like I know so is the point you're making that two basidiocarps look the same, but you're saying that the nuclear information in certain cases is radically different, and so therefore that's not the same thing. That's the point you're making.
Yeah, you can
Okay.
take a Tesla and cut out the electric engine and put a gas engine in there and like hide the exhaust port. It still looks like a Tesla,
Right.
but it's not. On the inside,
Okay.
the entire content of it is different.
My uncle would buy that if you built that, by the way. Yeah.
A gas-powered Tesla? Yeah, that sounds pretty cool.
Yeah. Okay, so I finally get it. That makes sense. I see the differentiation here. That only by using the molecular information are you able to realize that you've sort of been fooled. And I'm assuming that's what Steve's saying is a lot of the field guides then are going by sort of macro and micro observational, sketches of basidia, things like this. Whereas there's so much diversity in the world that there are two basidiocarps that look the same, but on a DNA level, they're not just slightly different. In the case you mentioned, they're significantly different.
And I would say whether or not it matters just depends on what your goals are. So there's probably something like 5 species of Lactarius in North America. Lactarius indigo in North America. Does it really matter functionally for the average person that there's actually 5 separate species of Lactarius, or does the field guide calling them all Lactarius indigo, is that sufficient for most people's goals? And I think the obvious answer is, it doesn't. That higher level of precision is just not necessary for most goals.
Yep. If you're just looking to put it on your plate, you just need to know that's the right group. I kind of like how that group tastes. Move on.
Right.
But it can kind of help us see bigger pictures too. I think if you even go up a couple taxonomic levels, right? Because we know within fungi, phenotype doesn't always correspond to genotype really well. I think that's really easy to see with the guild boletes, right? Anybody that's ever found those, you look at them and you're like, you can see why people for a long time thought these should be Indigaricles, right? They look more like something Indigaricles. They've got gills, etc. If you get them underneath a microscope, then at first you might go, oh, maybe the spores look a lot more like, boletes. And then once you do, genetic work, then you're like, okay, yeah, they're definitely in the same clade. And it's just, we'll continue to get that precision, but like Steve says, it's like, what are you trying to get from it? What is that precision, that accuracy ultimately getting you in your goal as a mycologist or somebody that just is foraging, etc., is always the kind of thing to keep on the radar.
But for the future, as people, researchers are going to be trying to, utilize fungi to derive certain compounds and things like this, it does get more crucial to be more specific. That would be the point, to be more accurate, to go, all right, you can't just here's the fruit, and when we do an extract from this fruit, it has this medicinal property, and somebody goes, oh, I have that fruit in the backyard, I'm going to do that, and it might not be the same thing. That's kind of why it matters.
Right.
Which makes sense.
Yeah, and I would say there's a journal dedicated to medicinal mushrooms, and they've actually said in an article that that's a very serious issue within the entire literature of medicinal mushroom research, is actually making sure that the species that are evaluated in a study for a specific pharmacological purpose are actually the ones being reported. Because without any genetic information going along with that, in many cases, it's not. And that essentially puts, if they aren't even reporting on the species that they're intending to, that just throws the whole paper into the trash can, essentially. And that's been a big problem historically.
I think I know the article you're referring to. It sort of had a blueprint for going forward, like how they would hope people who are trying to derive compounds would, follow certain protocols, and would definitely use ITS sequencing and maybe occasionally use some RB sequencing, other things for certain very specific groups of harder to identify fungi. But yeah, they made it pretty clear in that article that they're like, gotta know very precisely what you're talking about here, and molecular data backs that up very, very well.
And the same could be true for almost any domain of mycology. So I often refer to, the work that I'm interested in is really foundational for every other aspect of the science. So, even for something like mushroom cultivation, take that same analogy with the medicinal mushrooms. If you're reporting on all of these cultivation parameters of a specific species, and things that work, things that don't, and you don't even have the species right, or there's multiple species within the group, and they're all being conflated into one study, your data is just essentially worthless, right? Maybe not worthless, but just not as accurate.
Might or
as
might
it
not.
Could. Yeah, might or might not be useful.
Yeah.
And so it's really like that for every other domain that might use mycological information. So people interested in tracking climate change, looking at the species range changes over the course of time. If you're not tracking the right species, or there's multiple species involved in what you're tracking, and you don't know that, your data is fundamentally flawed. And so you could just kind of extrapolate this across every other domain. And so that's why I often say in my talks, understanding what occurs, where it occurs, and when it occurs is really foundational knowledge for every other aspect of mycological sciences.
Right. Well, and if I remember correctly from that article, I think it said like less than 3% or 5% of the estimated number of fungal species that they think exist in the world have actually been identified, and even less of them have been sequenced. So there's just a lot of work to do.
I would guess in North America, probably at least 50% of the mushrooms are left to be described. Wow. So, even here in North America, there's just a fundamentally large amount of work that has to be done.
Right.
And so, even in, let's take that thought process we were just going through a little further. So talking about, kind of the future of mycology or something like that, people, with something like iNaturalists, they're trying to use these machine learning algorithms in order to identify species. Well, if the majority of the species on iNaturalist are not accurately identified, or they're composites of multiple species, you're never going to get to an end result for most species. So a lot of the most common species it's pretty good at identifying, but for most of the species out there, it's never going to be good because the species aren't even described yet, much less segregated into buckets to where the algorithm can, put the right photographs all into the right buckets to be able to, and so that, especially for a lot of the work within, these machine learning algorithms, they're never going to get to the point to where they can accurately identify most things until this foundational work is really done, to accurately and precisely segregate these things into the proper in species level units, however you want to define a species.
Right.
And what even complicates that even more, even if you do have the right genotype associated with it, all the different phenotypic expressions of the same genome can be really big depending upon the environment that thing is growing in.
Right.
And so I think, a lot of the AI stuff has a lot of hiccups when it comes to phenotypic expression, even off of the same individual genome.
Yeah, man, mushrooms.
And that's why this is like so important to like this, of getting these, at least first looks with ITS for all the things that are out there. Because at least then we know kind of the ground level, and then we can kind of build up our repertoire from there.
Then it just gets more the same way that Nanopore gets more sophisticated. Yeah, the molecular data sets get more sophisticated, and we can do more with it. Now, somebody asked a question here.
And also, the more we know, the more we know we don't know.
Oh, that's always that way, yeah.
Very true.
All right. Village Bobcat had a question. He said, with the information y'all are bringing forward, does that make it easier for pharma companies to begin creating?
I don't think at the ITS barcoding level it necessarily does. It's just helping us understand, like we were talking about before, the baseline of like what is out there. For really creating, that's talking about getting whole genome sequencing done for individuals. That's where you all of a sudden are opening the toolbox for synthetic biology to actually harvest mycological genomes to then do creative stuff with them.
But they need that. They need that genome.
They'll need more of bigger chunks of the genome besides just ITS to do something creative. Creating with a bunch of ITS isn't going to get you anything exciting.
Yeah, it's too conserved. I mean, it doesn't do anything.
But,
you
but
need
it
where
helps,
the action is.
Yeah, but it does help you have the go-to tag, right, to say, okay, it is from this organism at this other section of the genome that I'm looking at that I want to create with. So it is very foundational because it gives us the language to talk about what bin to go look in for those tools to then create with.
And I would also say that a lot of this work of collecting specimens is also starting to build a biodiversity library of modern collections with DNA that's not completely degraded, like that's in most herbaria. So if you look behind me, these are all my cabinets of the herbarium in my lab, and so we're really starting to build this very large scale biodiversity library that's all with a first outline. It all just has ITS. DNA barcodes, but in the future there's going to be opportunities as the sequencing technologies continue to progress, as they get cheaper, to go back through the library behind me for full genomes. And now that we actually have these things, we know where we want to look. We're going to be able to target specific species for whole genomes as it becomes cheaper, more readily available. But yeah, right now I'm primarily interested in just building the biodiversity library, as well as giving it an overall an initial outline, which is the ITS region.
Right. And then the great thing, especially in Indiana, that you're doing is you are nanoporing all this stuff. So even in the future, 50 years in the future, you will have old data that can be reanalyzed and compared with new data as well, which might or might not in certain situations amount to more interesting discoveries or shifts, especially as I'm sure Damon's maybe interested in this. I mean, as we just keep fucking our planet up, right? And populations are gone or moving or evolving, trying to evolve.
We're gonna have a de-extinction project around a fungus in my lifetime, aren't we?
Right,
Probably.
You know what I mean? Like that's you're chronicling that information in your state. I mean, I don't know if Indiana is is going to be the first state to go down in flames, environmentally speaking. I'm pretty sure there's many other states that are probably on the top 10 list. But you know what I mean? That's cool that you're taking that on and that you're trying to build that library. From what I hear, there's just herbariums with a lot of old little crunched up pieces of mushrooms sitting in, like, you know, empty cigarette boxes and stuff like that having new modern fungariums is kind of cool, kind of necessary.
This also gets to what Stephen said before about the reconceptualizing how we want to think about the taxonomy in bins, because one of the things that slows down a whole lot of this, like putting the appropriate Latin name on stuff, is that a lot of the holotypes for a lot of these things we've been using names for are so old and degraded, we'll never really have a good sequence for them out of the holotype. And it would be a heck of a lot of work for somebody to go out and try and collect from the same location, get sequence and all that. So you're quickly converting me to bin theory of taxonomy for sure tonight.
Yeah, we've talked about that. What do you do if you don't have, so the new evolution is molecular data, and yet all these species that we've identified, you can't get at the holotype at all. I mean, if it's even there, or if there's any DNA that survived to look at. Now, if Nanopore gets really good, wouldn't that be exciting if you could go in to these herbariums and sequence the fuck out of all this stuff? That would be pretty cool.
That's actually something I've started. So I actually have a meeting tomorrow with one of the top fungarias in the country. So I mentioned early on in this that I'm actually taking a new job, and it's going to be at the University of Michigan, starting here in a couple weeks.
Ooh, nice.
So
they have a great herbarium.
Yeah, not as a professor. So there's a biomedical research store, essentially where labs can go to get laboratory supplies, and so the director of that research store. But that puts me in the proximity to one of the top fungaria in the country, and so that's essentially going to be the plan, is to sequence everything there.
They'll let you, because it's just sitting there.
Oh yeah, I'm sure they'll let me. But I think it'll be really interesting to see from a lot of perspectives, just everything we've been been talking about. So how many of these things are actually going to be able to be sequenced? What's the the age range to where you see significant things dropping off? How many of these holotypes have multiple species within the same box? How many of how many of the paratypes? So these are things that were used as a part of the original description, but it's not the holotype. How many of these are not even the same? And so when you start, there's going to be so many more fundamental issues that, like Damon was just talking about, the bin method, to me, it's almost the way to go, and not even to worry about any of this for right now. But that doesn't mean, I still really don't understand why the professional community hasn't made this a higher priority. It's 2023, and we still haven't sequenced most of these type specimens. To me, that's kind of a failing of the science at large, to where some asshole from Indiana has to go in and be the one, to do this. I mean, Are you serious? But that's the way that it is.
Well, let's talk about all the places you can get a mycology degree. Oh, wait.
Yeah.
That's a short conversation now. Yeah.
Yep.
Well, and also, we do incentivize academics, right, to basically produce papers, right, and not necessarily take on grand projects.
Right.
And so I think part of it is just the incentive system within academia is also not set up to kind of do what Stephen is trying to do, which is a shortfalling, right, of how we've allowed academia to set up itself.
Sure. Well, I was talking to somebody the other day about how scientists of the good old days had very little concern about financial gain in their research, right? It was all about the research, and now you have the young breed of scientists, and if they're really smart and really know what they're doing and got their finger on the pulse of the new technology, man, all they're doing is plotting how to get rich off it. They want to, so sequencing herbarium specimens, where is that going to get you? It's not going to It's not going to get you that Tesla you want to buy and take the engine out of and put a gasoline engine in it, right? So, I mean, you guys can act like that's not true, but I know for a fact, I've met some of these people. There are definitely capitalist scientists now. I mean, that is definitely a thing. So yeah, you're right. Steve's got to be the guy in Indiana to do it, and hopefully going over to Ann Arbor is going to allow him to do that, but you're not going to find many young buck scientists, you know, with
so
big
we're
IQs
going to send
looking
the
to
bottles
do
of
that.
whiskey to keep fueling Steve at?
Yes.
Yep. Cheers to
I
that.
got a few for you.
Yeah.
There's lots of good places to get whiskey up in Ann Arbor. You'll be good. So you're moving to Ann Arbor?
Yeah, here in a couple weeks.
Oh, you'll
So,
love it there,
yeah,
man. It's such a cool city. Well, town.
Sure
I don't
is.
know. I guess you can't call it a city, but yeah, you have a good time. I know Kyle can't openly endorse Ann Arbor being a great city from where we
I
live.
can though. I'm kind of jealous that he's moving up there now. Dang.
Yeah, man, you'll like it there. There's a lot of cool nerds up in Ann Arbor.
Yeah.
Yeah, for sure.
Good place. Yeah.
I call it the Berkeley of Michigan.
Yeah, so before I I'm actually living in my hometown right now, and it was kind of a fluke that we ended up back here. I was finishing up at Purdue for some graduate work, and we decided to come live back with our parents for the summer before we moved back down to Bloomington, Indiana, which is another college town. It's where my daughter was born. I have a 7-year-old daughter. And we both ended up getting offered jobs while we were here, and we've been here for about 3 years now, and we're quite ready to retreat from this situation. Hometown's like 30,000 people in north central Indiana, so college towns typically have just a lot more to do and more interest. They're like intellectual capitals of a given area, and it's just more interesting environment. And so we've been ready to make a move. We were planning on Bloomington, but the right position opened up in Ann Arbor. So
You're gonna have nothing but fun up there, I promise you.
Oh, that's all.
Yeah, that's great. Well, so what are the next year? What are the things on your guys' radar? We now know Steve's moving, but yeah, what mycology wise, what are you guys all doing this year? Kyle, you're learning Minion.
Yep. Correct.
We're gonna go foraging.
Yep.
Yep.
I just need to kind of get my project out there in the state of Ohio. That's what I've been working on. I was inspired by Steven and his group of people over there in Indiana collecting mushrooms everywhere. So I'm kind of working on building a clientele base in Ohio of people to get excited about this project. And that's my goal. Then I'm going to attend, most of the Ohio Mushroom Society forays and scoop everything off of those tables. I'll be at a couple I'll be at the NAMA event in North Carolina, hoping to do some sequencing there. So yeah, that's my game plan is to stay out. I'm trying to dedicate every day in the old growth forest in June. So I'm going to see if I can manage that. So every day in June, I'm going to try to be out and then encouraging others to be out. And then, just sequencing everything we come up with this year, as well as some university herbariums in Ohio as well.
That's great. I think there's a good one in Youngstown.
Yeah, I've heard of that one. Yep, Youngstown, I have my eye on that one. Miami University down in Oxford's got one.
Yeah.
It's pretty nice. And then Bluffton University has a private one from somebody that I know that manages this.
Oh, I didn't know that one.
Yeah.
Nice. So in the future, I'll help get the word out. But yeah, Kyle needs mushrooms. Steve needs mushrooms. We'll get you guys mushrooms. You got all those wells. We just got to put mushrooms in them. Hart, how about you? What are you aggressively trying to collect mushrooms, or what's going on with you with Nanopore?
Yeah, so currently I work for, I actually get to do mycology for a living. I work for the Fungal Diversity Survey. We're a nonprofit. We got a grant from the state of California to basically try to create an inventory of all the species of fungi in California, which is a impossible task, but we're going to do our best. So we've got folks out in the field collecting the mushrooms. Currently, right now, we're using Sanger sequencing. But I picked up Nanopore because Sanger sequencing is expensive, and we could easily do 10 times more work and
Right.
for 10 times less money using this Nanopore. So I'll be running the sequencing for Fundus for the Fungal Diversity Survey. And then in the fall, I'll be starting a master's program, hopefully doing something around fungal genomics. We'll see what there's money for. Speaking of your earlier comment, yeah, there's the money either goes to plant pathology or towards pharmaceutical development. So if you
Big pharma and agriculture, it makes sense. I'm not mad at it, but that's why we sit back and go, why don't we know this about mushrooms? Why don't we know this about mycelium? We talk about it in our agar work all the time, where it's just like, we know a lot, but we also don't know a lot of stuff. But agriculture got all the money.
If only it was attacking corn.
Yeah, if only it was attacking corn.
I'm pretty lucky though. The university I go to got a really, really large grant, and they're part of this organization called the Green Biome Institute, and that's the primary goal of that is to sequence the whole genome of all the rare plants of California, all the rarest plants, and also do the associated proteome work, so to identify all the proteins. Basically create a blueprint for these organisms. And part of that includes the microbiome, which is going to also include all the fungi that grow on these plants. So if you take a leaf from any plant and you sequence all the fungi in it, you get hundreds or thousands of species of fungi that simply live inside the leaf of these plants. And likewise with any of the tissues of the plant. So I'll be able to do some of that kind of work. And I'm going to continue doing my work with the Entheogen Genome Foundation. And their goal is to sequence the genome of all the entheogenic organisms on the planet. We're starting with fungi because genomes are small and it's much cheaper. So we are doing Nanopore first, but then we also purchase Illumina sequencing if the genome needs polishing. And the goal of that project is to release all this information publicly. We don't want pharma companies doing this work ahead of us and then developing patented substances out of this. We want this to be completely publicly
it's a race, and we need you guys to win. Yes. That's cool.
So that's what my next year looks like.
Very cool. So Steve, I'll have to come up and say hi one time. I cruise through Ann Arbor fairly frequently, especially if you're getting good over at the herbarium over there, and can get me a nice tour over there. That would be fun. Damon, how about you? What's up for this year?
Mine's looking a lot less exciting than the other three, but probably still a lot of teaching just PCR to folks, and that's mainly going to be through the day job. But getting more high school students basically learning PCR, which then can feed into any of these pipelines as scaling up. I think the only big fungal thing on the horizon is probably hopefully getting to do fungi at the Sky Islands again, which Hart's was essential in last year, and like Christian Schwartz had been really involved in a couple years ago, which is kind of a week more or less of collection out in southeast Arizona, followed by sequencing of a lot of those specimens.
Now, where is that?
Southeast Arizona, so you're talking kind of like south and east of Tucson by about 2 hours or so.
Okay.
You just have some crazy diversity there, and when you start mapping it out, a lot of these things map back to the East Coast or map out to the West Coast, and then occasionally in the Rockies. There's just some really cool kind of biodiversity and also long-scale kind of geology looks that you can see through understanding the taxonomy there.
Nice. Man, I got a buddy, Spencer. He's in Arizona, and he's finding cool stuff all the time. So maybe I have to get out for that. He's one of the few I would really love to meet. So, and he forages all the time. So he's definitely tempted me out that way. So
yeah, Spencer was involved in last year's Desperado version of the course. He's awesome dude. Knows his cultivation inside and out. Brought down some cool specimens for us to get on auger. Yeah.
Nice. Cool, guys. Well, I think we did it. We got 2.5 hours in. I'm definitely motivated. I've told Kyle about 5 times now, okay, in 2 days I'm doing it. I'm doing my first extractions, and it hasn't happened yet. I've had all sorts of stuff, work stuff, kid stuff. Wow, kids, they really don't tell you how much work and time and energy they are. I mean, it's rewarding, but it definitely gets in the way of my sequencing, because I'm also doing the podcast and growing mushrooms, and yeah, so it's a lot. I gotta figure out, I gotta redistribute my pie, so to speak, to get the PCR involved in here next. But anyway, this has been great. I'm sure we'll have to have you guys on in varying ways and for varying reasons in the future. If you guys ever need me to shout something out or to let people know, hey, we're doing a big push for this, or I'm going to be out here doing such and such, just let me know. I'd love to let people know where you're at and what you guys are up to. You guys are really important educators as far as this stuff goes, so I really appreciate it.
Yeah, many thanks.
Thank you.
And
thanks for having us on.
Thank you.
so I should also say, the last segment here we do with Ed, we call it Deep Science. Sometimes it is deep, sometimes it's not. I know you guys have said some things that he would love to talk to you guys about. If you guys want to stick around, that's great. If you guys need to get going, I also understand. So just let me know if you want to stick around. Otherwise, I will wish you a good evening and talk to you guys soon.
Nice.
Anybody staying, going?
I'll stick around. Let me get a beer.
Okay.
Yeah, I was going
That's
to say,
fine.
I'm going to have to pop out for a second, but I can pop back in.
Cool. Okay. All right.
For a little bit.
If you gotta go, it's okay. You can just say, hey guys, I gotta go. That's fine. We'll do it casual like that. All right. Let me pull Ed in here. All right, guys. Just so you know, and so I can keep track of my chapters here. We're in the deep science. You know it. It's official. We're going even deeper. We were in the shallow end of the deep science. Now it's going much deeper. I'm kidding. It's probably going to stay in the same depth. Oh yeah, I think I hear you, but keep talking. I might adjust your.
Oh yeah, I might need to adjust my little thingy here.
Oh no,
Is that
I
okay?
gotcha. I gotcha.
Oh,
I had you
good.
down.
Yeah, I just
for
gotta
some
make
reason.
sure I push my thing away and forget to put it back.
It's okay. You just make a terrible air traffic controller. That's all.
I know. I'd be like, yeah, AL42, 46, and then it'd be like, what? What was that? Yeah.
Crash
Oh, you
and
got me
burn.
thinking that airplane movie. That is like one of the best movies ever.
It
Look
really
like I picked the
never-
wrong day to stop doing methamphetamine.
It's a good movie.
What? It was the wrong day to stop sniffing glue.
Yes.
No, that's later.
So some before we had a list of topics we wanted to cover, Ed. But before we did, you were not, I wouldn't use the term animated, but you had some thoughts, and instead of address them during the main section, I figured we would put it in your segment. Ed is an absolutely, like, his thesis advisor was Ron Carlson, who used to be like the chairman of
Peterson.
what did I say? Carlson? Who's Ron Carlson?
Yeah, I thought you were using a pseudonym, but it was Peterson. UT Ron
I don't
Peterson.
know why
He's
I
still
kept
kicking
saying
it.
Ron Carlson.
I thought you were kind of like trying to keep it anonymous, but he's a well-known dick. Everybody knows him. He's at UT Knoxville.
But yeah, so
Like if you ever
he's
meet
like,
him, you'll know because you'll be like, "Wow, that guy was a dick."
I watched a
Like,
video.
who's
He
that?
seemed like a nice guy, dude. I don't know.
No, he is actually. I'm just joking. He would know I'm joking. But yeah, he
Yeah.
is a bit of a dick.
He's a
he knows
nice
he is.
dick.
He's proud
Yes.
to be a dick. That's the thing.
Okay.
You have to embrace your
Inner dick.
calling.
Yes.
Yes, your inner dick. I think I do that a lot. Like,
Oh my god.
okay, what?
Anyway, so
Phylogenies.
Ed introduced me to the term lumper, or the idea of lumpers and splitters.
Yeah.
And I don't know if I know which one I am. I might be just slightly more of a lumper than a splitter, although the splitting is fun. So anyway, as you guys are talking definitely about splitting, although Damon's talking about binning. So now we have lumper, splitters,
I don't really
and
know
binners.
What Damon means by binner.
Do you mean like
clades?
clades?
That means throw it in the garbage in
I can't handle any of that. Just in the trash. No, it was more the idea of like what Stephen was saying. It was like, you don't necessarily need a name for it. We just need to be able to say, hey, this is different than this, so I'm going to put it into this bin over here. Which, to some degree, that, definitely splitter, right? But that's because we can see more granularity.
Wait, but isn't that a name? I mean, when you say, like, that's a Homo sapiens, is that the bin for, like, Asians, black people, and white people? Is that what you mean by bin? It sounds like you're describing exactly what would be the definition of a species.
So the bins would represent individual species, and they could. The main reason that I think in terms of concepts of bins right now is just the vast amount of work that needs to be done. And we're not going to have within the next 50 years, we're not going to have a high percentage of names on any of these bins. Any of these things that we can define clearly as species that we believe represent an individual species. It's just going to take.
So wait, I got a question. Yeah. Why don't you just call it a clade instead of a bin?
I mean, you could, but I would say.
Why not? Because I've never, in my years of doing this, ever heard the term bin referred to as like a clade. We don't need to introduce inaccurate terminology.
I think what's going on here is you're getting the taxonomist meeting bioinformatics. In bioinformatics, a lot of times we talk about being able to bin things that are the same. And so it's these two worlds colliding right now.
That is what it is.
And now our nomenclature control police rolling in and being like, hey, hold on.
But I would say
it's well established. It's codified for the last 50 years. The ICBN, there's a codification of naming and tech. Like you guys are kind of like, I'm hearing like you're basically like, fuck every rule we've made for the last 200 years of mycology. Throw that in the bin, and let's just make up all this new shit that has nothing to do with anything. There's hundreds of years of taxonomy and morphology, and you guys are all just like, well, fuck it, I got a DNA sequence. Like, let's throw it in that bin. No, when you guys say Lactarius indigo, what the fuck do you mean? Why don't you just call it Lactarius indigo? There doesn't need to be a bin. Just call it morphological plasticity and say Lactarius indigo is morphologically plastic, and it expresses itself differently in different ecotypes. You don't have to throw it in a bin. Just call it what it is.
I think we're circling, kind of like Damon was saying, we're circling around two different philosophies on how to look at this thing. And so when we're talking about, it's not when we're talking about Lactarius indigo. Yeah, you could just say they're all Lactarius indigo. I'm lumping them all together. They have these unique DNA sequences. They have unique morphology. You could just say, yeah, I'm going with what we've always said is Lactarius indigo. But based on the DNA, we know there's 5 different buckets, 5 different bins, 5 different clades. If that terminology works better for you, that only one of them.
Names. You should give those 5 different names then.
Yeah,
whether those names are based on the phylocode or traditional taxonomy and history and the literature. Alexander Smith has a monograph about the genus Lactarius. You should go back to that, and if he indicated that there were 5 appropriately published names, you should use those names.
Well, Smith fucked up a whole lot of that, by the way.
So, like with
okay, now you're fucking dissing Alexander Smith. Who's going to Ann Arbor?
If you
guys are really getting into blasphemous territory.
If you look at
what's the oldest one of you guys? How old are you? Like, what are you guys, like 40, 45? And now you're fucking dissing Alexander Smith. What, you gonna shut down Alex Shulgin next too? Yeah, fuck Tim Leary, Alexander Shulgin. Like, come on, you guys. Alexander Smith. What's that? Like, Oakland guy out there?
Absolutely, Alexander Smith fucked up so many things. Really. Alexander Smith fucked up so many things. If you look at a recent Hebaloma paper,
and you're going to U of M, dude.
Listen. If
good luck. Go down to the herbarium and tell him Alex fucked up a bunch of stuff.
If you look at a recent,
get those holotypes from the herbarium.
That's the point I'm trying to make here.
All of which he probably collected.
Yes, if you look at a recent Hebaloma paper by Alexander Smith, from a single paper of his,
he's dead. He's dead, dude.
They had to
Alexander Smith is dead.
They had to synonymize 15 different names that he applied into one single species. He was the master splitter. But we now know by DNA, just for one single species of Hebeloma, him alone, he described the same species 15 different times. So you're talking to me about him not fucking shit up. It's completely fucked up. What are you talking about?
How do you know it's fucked up? By a DNA sequence that you have? By an ITS sequence?
Just look at the recent literature on...
No, like tell me, how is it fucked up?
Because...
You're the one talking about naming shit based on DNA sequences.
Yeah.
How did Alexander Smith fuck up
Because
Hebeloma?
15 of the different names that he used in Hebeloma, based on the DNA, are all a single species.
Based on the DNA, what does that mean?
They
have identical... So they have identical DNA?
Yes, they have identical DNA. He separated them based
so
on varying
on
morphological
ITS
features when they should have been conflated into a single species, but they represent a range of morphology that he described as 15 unique species when they should have been one single species.
We're all just like the Alexander Smith did not see the cube diversity that's out there right now.
Yes, it's all based on the holotype specimens from Alexander Smith.
Really?
Yes.
So U of M herbarium allowed you to destroy.
Not me.
Not
I'm
him.
saying this is some recent research that was done on Alexander Smith's holotypes for the genus Hebeloma.
I would love to see that. If you could give a reference to that, that would be
Oh yeah,
great.
definitely. I think it's like Hebeloma Revisited, or I can't remember the exact title, but they put out a couple recent papers based on Peck's types in New York, based on Smith's types in Michigan, and it's clear. It should be clear to everybody that problem is going to be
everybody
persistent
so it should be
throughout
clear
all
to
of
everybody.
That problem.
It's not clear to me, and you're not explaining it very well. So this was based on ITS sequence. Why did
Who is
have
this
entire? Who am I?
So I'd have to look.
Maybe you should look me up, dude.
I'd have to look back at what all genes were used, but I'm pretty sure it was based on multi-gene phylogenies of Smith's types.
You're pretty sure.
I'd have to,
and you don't remember who did it and what genes
well, it's
Henry, and what
Henry
algorithms they use and analyses they use. You just sort of know something that Alexander fucked up, like Hebeloma. That's very informative.
Well,
you're welcome.
I'll get the paper and we can look at it. I mean, it
I'll
is
be honest,
possible.
if I give any of you a Hebeloma, would you even be able to identify it? Do you know?
Depends on the
DNA?
Give me the macromorphological characteristic of Hebeloma. Give me 3 of them.
Well, it's got brown spores. They've got decoration on the stipe. They often have guttation on the gills. Like, what do you want to know?
Guttation on the gills. Well, that's not Hebeloma, and they don't have ornamentation on the stipe. I know a lot about them, dude. I don't know if you want to be calling me out, Mr. Hart. There, if that's who's talking, I don't know if you realize really quite what you're doing.
So Ed, I don't think any of these guys claim to be a Hebeloma expert. I think Steve was just talking about a paper, and now honestly, the paper was kind of opposite of how I expected the storyline to go. I think I would assume a lot of this revisiting of holotype DNA would result in maybe further differentiation of things, maybe. But this paper is just purporting to say that.
Okay, well, we get away
15
from
different
the paper
things.
We don't know where the paper is. I don't even know.
Well,
who
and
published
it's
it.
not just that. It's Sapharella too. If you look at other papers,
let's not go into other genera that you don't have references for.
Okay, I got the reference. 96 North American text assorted, Peck's Hebeloma revisited. I can post the DOI on it. But we should probably move on from...
Yeah, somebody that doesn't know 3 macroscopic of Hebeloma that grows, by the way, right outside the entrance at the U of M herbarium, as well as Sapharella and a variety of Caprinus species. So for people that couldn't identify a Caprinus Hebeloma, a Cortinarius, and differentiate them, I find it a little bit hard for somebody to say that the man who wrote the fucking monograph on the genera was like completely fucked up and didn't know what he was talking about. Like that's
Yeah,
a little bit of a stretch for me.
If you start looking at everything that's been published recently regarding any of Smith's taxa that he wrote these monographs on, basically every revisitation of Smith's types showed that he has been showing consistently. Satharella would be another recent paper that showed the same thing.
Wow.
That he would
Okay,
describe the same species.
Good luck in Ann Arbor. That's where Alexander Smith did all his work, right? Is at U of M.
Absolutely. That's the whole point of why I'm going into the herbarium, to continue that work, to get rid of all these superfluous names. There's a ton of...
Wow, so you've just, like, not only Smith, but, like, a lot of his colleagues worked in there, and you're just going to go in and basically sort them all out? Like the last 100 years of mycology, you're just going to sort out every mycologist of the 19th century. You're just I'll just go in there, do a little ITS sequencing, sort them all out, man, throw the ones in the garbage. Oh, superfluous name, fuck that, bin it.
Exactly. Yeah. I think you have the story.
To be fair, if you get all the holotypes and you sequence them and it's good data and it is all the same, I mean...
Yeah, I mean, I don't even know what this guy's talking about. It just... I mean, he's just showing that he obviously hasn't read any literature on any of these groups.
Wow, dude, you really, you motherfucker, are you really referring to me as this guy?
I guess so.
You want to get personal?
For tonight,
I've got a name. It's Edward Grand. Look it up on the UT Ph.D. website. You want to get all bitchy about it.
Okay.
You can get bitchy too.
All right. Okay, guys. I had hoped this would be a little bit more.
Yeah, I thought it would be. It's fully just into chaos.
I fully expected a little controversy, or I definitely expected a little.
I don't like
dialogue,
being disrespected. I don't like being he's calling me this guy. I have a name. It's Edward Grand.
I know it now. Thank you.
I mean, yeah, I think you probably just didn't know, but.
I don't like being disrespected, man. I'm a normal guy like you, but if you're gonna disrespect me, man, don't do that.
Okay.
Fair enough, Ed.
No one's disrespecting anybody on here. I definitely I think we're all just trying to talk about this. Anyway, I understand that. I'm some of these people. So I work in a hospital, right? I've worked in many hospitals. There are surgeons and there are doctors that you, right? Like if you challenged, you would just get put in your place real fast. Whether you're right or you're wrong, you would.
Don't get me wrong, Michael. Yeah, I'm just pointing out the fact that all these like cowboys that come in with their ITS sequencing and think they're going to rewrite mycology. Don't know anything about mycology or its history or the naming system. I'm sorry, but you guys are making yourself sound really ignorant. If a professional mycologist listened to this, they would be like me, just like my blood pressure has gone over 200 probably multiple times. You guys have made some, and again, I'm not trying to be disrespectful. You guys have made some horribly erroneous as well as very ignorant statements in the last 2 hours that if you were talking to a professional mycologist, would basically walk away from you and say, wow, you wonder, they will never allow you access to Smith's holotype. If they watch this and hear what you've said, they will never allow you to touch a holotype of Alexander Smith because of the things you guys have been. Supposedly you're coming in and you're going to rewrite this. Dude, I have done thousands of PCR. I've sequenced thousands of things. I worked in labs. That's the thing. You don't know who I am. That guy, Steve.
So Ed.
So look, let me just make one point. I wasn't with it since I came into this conversation with Ed into it. I have not talked about any work that I've been doing. I was simply referencing other work by other mycologists that he's taking issue with, and I have no idea why. All it's showing is that he hasn't read these papers.
So
you just told me. I've read Smith's monographs.
I know, and I'm saying it's antiquated. Based on recent work within mycology, but not by me, by other professionals.
Okay, so hold on, guys, Ed, I'm not a.
Hundreds of years of mycology out the window because you've got an ITS sequence.
I don't have anything.
It's not his research. It's not his research.
that he doesn't have references for.
I'm looking at it right now.
He just MycoGeeky just referenced it.
I can share it. Hold on one second.
I'm sorry, Hebeloma is not my interest right now. There's thousands of papers that come out every day. I don't have the time to read them all.
Right.
Since you don't know the macromorphological characters of Hemeloba, and you're derisively saying I haven't read the paper, I'm sorry, Hebeloma and the Quaternariaceae is not my expertise or my area of interest. So I'm sorry if I'm not well versed on Hebeloma, but I am familiar with Alexander Smith's monographs.
All right, this is the reference paper. It's not Steve's, it's not Hart's, it's not Damon's.
I don't see what relevance this has, to be honest.
He's just it's published in.
So he was mentioning Lactarius also. Lactarius is probably a more prominent genus. Hebeloma is a small LBM that most people don't care about. So the fact that Alexander Smith got it a little bit wrong, based on his macromorphological characteristics and a microscope, and he didn't have ITS sequences 50, 60 years ago, I'm sorry that he might have got something wrong.
Right.
I would expect that anybody with a little bit of experience in field taxonomy would understand that there's morphological variations that are in every taxa. And so that he wasn't dealing with DNA sequences and didn't have all this fancy stuff.
Which is exactly what I think I just explained a little bit ago. That there's a range of morphological variation for many of Peck's descriptions, and he was the master splitter.
Peck or Smith? Who are we talking about now, Peck or Smith?
Smith.
You just said
Smith.
Peck.
Okay.
That's a different mycologist.
The Peck paper just was popped up. Smith, and the same is true for his Satharellas. There's another recent paper.
So now we're going after Satharella Lactarius.
There's another recent paper that has sequenced a whole bunch of his types of Satharella that shows he was splitting in places where it was not appropriate. And it's not a big stretch to say.
But he didn't know, he didn't know any better, though. He didn't.
He didn't have the tools we have today.
He didn't know. He was doing great work at the time. In this case, DNA is showing that things he splitted were just phenotypically different expressions of the same thing.
And so I don't think it's a big stretch to think that if someone were to look at Lactarius in his Lactarius monograph in the same context, that you would, I would speculate that you would likely to find the same series of events to where he was a master splitter and split in many places where it was not otherwise appropriate.
Can we get off Alexander Smith? That's like most people probably have no idea who he is. I can tell you from experience, this is what happens to a lot of first-year graduate students is they come in and they get all this sequence and they want to split everything because they want to name stuff. That's how you get papers published. And so there's a lot of people, everybody here included, who would like to name something after their girlfriend or their dog or their first child. That's what people like to do. That has been a tradition in biology and everything else. You find a new type of snail, you name it after your first dog. I'm sorry, but just because someone does that, I don't think that's a reason to degrade their entire career.
I'm not degrading his career. Yeah, you're putting words in my mouth that did not come out of my mouth. So I have nothing but respect for Smith. I think he was an awesome mycologist. I just think he split too frequently.
Well, a lot of people...
But he didn't know... to be fair, he just... Do you think he split too frequently without the DNA information?
Of where you're going, Myco. It's the opposite. Is because he had a lot of experience in the field. He was like the quintessential field mycologist. He went out every weekend with the Michigan Mushroom Hunters Club, twice a weekend, and he saw what was in the field, so he understood morphological plasticity. Now, this comes after seeing hundreds and hundreds and hundreds of the same species over and over and over again. Now, when you pull out a dried species from an herbarium box and you look at it, it looks nothing like the original thing that you saw out in the woods. So his intention would have been to help the average person, which is what he was interested in. He was an academic. He published a lot. And this is not just Smith. This is everybody. They're trying to help the public. And I get the impression you guys are forming this elitist group of I've got my gel electrophoresis. You don't know shit if you don't got my ITS sequence and you don't got blast and you don't have my you don't know shit. You don't know what Lactarius deliciosus is anymore because you don't have the ITS sequence. You don't know what Satharella candeliana is. Like, you don't have the ITS sequence. Like, now we have to come to you to get an ITS sequence to just figure out what a mushroom is out in my front yard. Like, I need an ITS sequence for that. I could take you out in the woods right now and show you 400 species of mushrooms based on macromorphology. I don't need an ITS sequence. And this is ironic because that's what my PhD was about, was ITS sequences. Yeah. I still know macromorphology.
So
I get the impression you guys don't.
I think you're missing the big... Yeah, go ahead, Hart.
Okay, hold on. Okay. Hart, what do you have to say?
And nobody's trying to discredit anybody's work here. Macromorphology is great, but the problem is that the content of these organisms, where you're looking at the mushroom is the sexually reproductive structure. Sometimes it's asexual. You're looking at a very small... You don't understand. You're looking at a very small... You don't need to explain it to me.
I know he's not explaining it to you, Ed. I think he's just explaining it to the viewers.
It's a thing called context for the viewers.
Yeah, he's not... He's just trying to keep it in perspective.
These things can look the same, but they can be functionally very different in the environment. And you know that. So what is the big argument about?
I don't know. What's your point?
So why should we not differentiate things based on their ecological context, which is inferred to a large degree by looking at their DNA? For something that associates
I can do that. No, you just said their ecological context. Why don't you just do it based on that?
Well, sometimes you don't know their ecological context. You don't know.
Well, if it grows under a pine tree, if it grows under like a red pine or a white pine or an oak tree or a yew bush, I think I can figure that out, and I can give those different species or variety names based on their ecological niche.
Well,
I don't need DNA sequence for that.
Sequencing would
like
tell you
if I see a Amanita muscaria and it's yellow and it's grown under white pine in Michigan, I know that's variety Formosa. If I find it in the West and it's white growing under some kind of spruce, I know it's variety Alba. I don't know exactly if that's right, but I can look at its color. I've got variety muscaria, Alba, Formosa. I can base that on its color and its host.
Can I give you a specific example?
Please
do. Are you familiar with the fungus Chinella pediophila? It's a truffle. It's a gasteroid fungus. It's in the G. australis. It has little peridioles that contain the spores. And it's very rare in the western United States. On iNaturalist, there might be like 10 observations of it. It's more common in Europe. Now, we recently took an expedition to this place called the Cedars. It's a very rare habitat. It's all... Sargent cypress, it's serpentine endemic trees there. We found a whole ton of the Chinella pediophila. The sequence of that matches Chinella pediophila from Morocco and from Spain. Cool. So those are probably the same species. Chinella pediophila, collected just 100 miles north of here, is only a 93% match. Macromorphologically, identical. I didn't do microscopy, so I couldn't tell you if the micro characteristics are different, but otherwise completely identical. So they grow with different trees in Europe than they do here. The same species. It was found under Pinus halepensis in Italy and Greece and Morocco and Spain. Here it's under Sargent cypress. Identical ITS sequence. The one that's nearby under...
So wait, I'm confused. Before you go on, what's the point of all this?
I'm trying to tell you that just because they're morphologically identical does not mean that they have an identical ecology. You have two things that are separate by 7% in ITS, which is very significant difference. So
yeah, but that's well known. I mean, Amanita there's a lot of mushroom species that are known from various types of hardwoods. Russulas grow under all kinds of hardwoods. I don't know what your point is.
So you don't necessarily know what a species is based on the outward ecology, just by looking at the trees. So
you knew it was Chinella, right? When you saw it, you identified it as Chinella?
Yeah.
Did you need the DNA sequence to do that, or did you just pick it up and say, oh, that's Chinella?
No, but you need the DNA sequence to know that the one that grows 100 miles of north is completely different than the one...
No. Have you heard of SNPs in humans? If I walk out my front door, I live in Thailand, there's probably at least maybe a 0.001% difference. But that, if I look at that DNA, the SNPs, the SNPs in human populations is a huge range of variety. But if I look at most of the other DNA, we're 99.99% similar. So again, I'm not sure. You guys are confused. You guys are stuck in
But
the
we're not
ITS
looking in
world.
variable regions. We're specifically going after regions that we know are tightly conserved.
ITS has a lot of conserved
That's the
evolution.
problem.
So
You guys aren't being specific. You're saying sequencing. Do you mean ITS? Do you mean like large subunit? Means RPB genes? Are you talking about Cox genes?
That's
are
kind
all
of irrelevant.
like you guys.
Those are all very conserved.
No, oh my God, dude, really irrelevant. Okay, that's irrelevant. Hart.
But we are looking
Alan,
at
right?
ITS. We've been discussing ITS.
So wait,
this
you just
entire
told,
time.
wait. Let me get this straight. Did you just say the difference between ITS, LSU, and RPB is irrelevant?
In the sense that they're all highly conserved.
Oh wow, you guys are more ignorant than I thought.
But Ed, he's saying compared to variable regions, they're the go-to regions for identification because they're typically conserved. That's all he's saying.
No,
he's not.
They have different levels of
that's
specificity.
wrong. That's wrong, dude. You need to talk about reading papers. You need to go back to 1990, like White et al. Like the ones where you get your ITS primers. What you're saying that oh my gosh, I don't even know where to start.
No, so all you're saying, Hart, is that there's within 100-mile span, there is what appear to be the same mushroom, but with 7% difference in ITS.
Yeah. So they must be very genetically distinct to have such a large difference.
Oh gosh, I don't know where to start with you guys.
Well,
you're telling me that if you pull out an ITS sequence and you do let's say an LSU sequence, you can get the same phylogenetic inferences based on those two data sets. So large subunit data set and an ITS data set and an RPB2 data set is going to give you the same phylogenetic tree.
Well,
is that what you're saying?
The example that you picked up was using SNPs to identify two different individuals, which is
let's go back to mushrooms.
The difference in precision between.
Let's go back to mushrooms. We don't need to go into the human thing. That was just an example.
Well, that was your example that you brought up.
Yeah, it's irrelevant. Let's go back to mushrooms. It's a different topic.
So you would use ITS, RPB2, and COX1, and all those for different levels of specificity. If you wanted to look at the difference.
Not specificity, taxonomic ranks.
Sure. Good. That's a better way of calling it. Taxonomic rank.
The correct way.
You wouldn't use.
If you're going to talk like you know what you're talking, use the correct names and the correct terminology. Don't make stuff up.
I should use the correct names. So it is taxonomic rank. But you would use LSU for a more zoomed out approach than you would ITS. But we've been talking about ITS the entire time. So that in the context of our discussion, it's ITS. But I don't think we need to argue semantics.
It's not and it's not arguing. It's just the truth. I'm not arguing. I'm telling you what the truth is.
So what is your truth? What is your truth? I really haven't understood your point that you're trying to get across. What?
I didn't have a.
I know. I don't think you have a point, but so we had this whole conversation on Smith.
Is that supposed to be is that like an insult? Are you being like derogatory?
We had a whole conversation.
You don't think I have a point? I can make lots of points, dude. I got like 2 Post-it notes full of them. I'm being nice. You want, dude? Don't fuck with me, man. I'm being nice. I'm being nice, man. This is nice, Ed. Ron Peterson was my advisor, dude. You just don't. I don't think you want to incite me. I'm being nice.
No, okay. Let's be nice. Let's just not threaten or. I mean, I love a good argument. I used to be the head of the debate team. I love a good argument, but let's just be nice about it.
So let's hear your Post-its. What are your points? I'm interested in hearing, and I'm sure the audience is too.
I was going to talk about something else. What do you want me to just set up a whole podcast now because you requested it?
Okay, guys. I'm going to interrupt real quick. We can go off of this. So, my quick little analysis of this, and who am I? I'm nobody. I don't own a MinION. I don't have a Ph.D. I'm just a guy in a basement running a podcast. But I'll tell you here's what I see playing out. Is Ed got a Ph.D. from a heavy hitter in Tennessee. He got a degree a while back when he was really in just the the birth of really seeing the power of DNA. That's what his thesis was on. But he really was, his thesis time was entrenched in the history of mycology, the importance of all the important work that people have done leading up to that point. We begin the segment with just a base level criticism of what is this guy's name? Alexander
Smith.
Alexander Smith. I've heard the name. I don't know what he did because I don't have a Ph.D. in mycology, but I know he's an important guy. All these old people that you know, you see their name Hart come up all the time, stuff like that, important people. So the first thing that's said isn't Alexander Smith, one of the most important mycologists of all time, did this, that, and the other thing. There is a paper. It is looking like perhaps, you know, he was splitting a little more than the DNA is suggesting, but it was more just heavy-handedly stated. It just looks like this guy really liked to split. And
okay, wait.
That
Can
is
we go back before this paper was based on ITS sequence? So I'm trying to explain the difference in the taxonomic. So if you looked at the LSU for Hebeloma and the LSU for Court, these are very different stories. Like you guys admittedly are talking about ITS. That's a whole different 3-hour conversation that we don't even need to have, because that involves cubes, and a lot of people are quite entrenched in that world. Now, if you want to talk about ITS, I did my whole fucking 4-year PhD on ITS. So if you want me to talk about that, I can do 3 podcasts on that.
Okay,
We've
so
attempted that.
I would love to get your perspective on it, because even though you were definitely upset, I love your perspective.
No, I'm not upset, dude.
And it's very valid.
This is what academics do. They
I
don't
know.
start insulting each other.
Sure.
See, this is the problem when somebody attacks you and insults you and says things like "that guy" or "let's hear your talk" or whatever. That means you don't know what you're talking about. Because if you had something to say, you'd have an actual question or some sort of statement instead of "let's hear what you know." This is what 18-year-old kids do now. They distract you from the original conversation. Sure. This is the classic. Like a guy the other day asked me, "Do you tip waiters?" We were talking about black holes, and I was trying to explain to him the event horizon.
Well, I'm staying on. I hear you. I get that point.
Let's not talk about Alexander Smith anymore.
Okay. Anyway, I only brought him up because I think that was sort of what instigated it. Is somebody that you were taught to have a deep respect for. Steve came in and said, "You see this new paper? It basically says this guy doesn't know what he's doing." And that's maybe how it came across. And I didn't
in Ann Arbor.
I didn't necessarily think that, but it definitely and look, man, I'm paying attention. I'm watching some of these new taxonomists are going to be more computer programmer than they are field mycologists for sure. And that's just, and so when Steve said, and Steve and Damon said the thing about you say clade and the bioinformatics people are saying bins, to me I'm like, oh cool, now we're into some relevant content. This is really true. This is really going to be an issue going forward, because Ed's not the only tried and true macro identifying field mycologist in the world, and there's going to be a lot of computer programming type sequence and dudes that are analyzing this data and going bin, and when everybody else is going clade, and so I think this is a great conversation. I do truly not think anyone's trying to insult anybody else here. I got nothing but respect for everybody. I think anyway. That's just
well,
my
the binning
2 cents.
concepts comes from the foray, the picnic tables. After you go out on a foray, if you ever go to a larger foray, you have 50 or 60 people out in the woods, and you come back and you put them all on the benches and the picnic tables, and you have lunch. And so the Lactarius phalemus goes in there, the Macrolepiodas go over there. And so when you go to the forays, like I led hundreds of forays, you come back and you see what people got from different parts of the woods under different hosts, maybe in different ages of maturity. And that gives you a sense of sort of the whole species, kind of complex, we might call them. In fact, that's more of a, I don't like the more proper term is say species complex rather than a bin. That was in fact in my PhD title, was the Lentinus tigrinus species complex based on ITS, morphology, and biological mating. So yeah, that's like kind of my thing. So to be basically like told I kind of don't know what I'm talking about is a little bit ironic to me, but we'll get past that. So the bin concept is what people call morphological plasticity. And what Hart was also referring to is also known as a thing called convergent evolution. So if you have whatever that genus was that the truffle that you were talking about, like things converge, and just because they have a slightly different ITS sequence doesn't mean that they're different. We know the meat and potatoes of what you guys do is to separate species based on their ITS difference, right? So on one hand you're saying like, oh, it doesn't fucking matter, throw them all in the same bin, and on another time you're saying like, we need to get all these new species discovered. But wait, we've got this new species, so you're saying basically a species, you're contradicting yourself. You're saying that if it has a different ITS sequence, it's a new species, put it in a different bin. And then others, I mean, then you're saying like, oh, well, fuck it, let's throw it all in the bin. Like Alexander was a splitter, he doesn't know what the fuck he's talking about. Throw it all in the bin. Like, you're contradicting yourself here.
So if they have a different ITS sequence from another specimen, they are by definition different. Nobody said they were different species.
Wait, different by whose definition? Different?
They have a different
Just the data
ITS
set
sequence,
is a different
so
data set.
they are by definition different in some way. Nobody said that they're different
DNA
species.
So
that's
my
why
DNA
the concept
is different from yours and from MycoGeeky's. We're different. I mean, you have to quantify what you mean different. Different is a sliding scale.
I'm trying to do that if I could speak for a second.
Okay.
So, they are by definition different. Nobody said they're different species. To define a species means you have to apply one or more species concepts. Why I like the definition or the concept of a bin rather than, this complex or whatever, is because it allows for different people with different species concepts who are looking at the data to be able to interpret it differently. Binning them by ITS similarity allows any of these further species concepts to be applied. You don't have to pick one. You could pick a morphological species concept, and the ITS bins would look different than they would if you picked the integrative species concept that looks at, phylogeny, more genes, ecology. So I mean, we're talking in circles here around.
I'm not. I'm not. I have a very linear thought pattern to everything I've said.
Okay. Well, I'm saying we're all discussing.
To you, then you're
okay. Hold on. So I'm gonna. So here's the thing. Ed, you are brilliant, and there are good points that I'm really wish people could hear that you're making. But you are definitely not calm and collected. You are definitely upset. It's okay. I get it. I actually side with you most of the time when it comes to the species stuff. I'm pretty much like, functionally speaking, I don't know if there's a benefit to going, well, this mushroom up here that can mate with the species down here, but has a 7% variation in base pair sequences out of 600 ITS nucleotides. Like, I could care less. If it can mate and make more dikaryotic mycelium that produces basidiocarps, to me, I could care less. So I hear so much of what you're saying, but no, Steve's trying to get on track. He's trying to talk through the points. He's trying to make his point. He's got every right to make a point. I would just love a really productive, not super. I mean, it's fun. Lots of people are loving the hotness of this.
No, I'd like to know that what was Steve's point is that we should integrate all of these things. We need to go somewhere. So are we going to use ITS?
I'll tell you.
We can have a real discussion. Why are we?
And I'm going to. So when he said they're distinct, here's the problem. This is again goes to the bioinformatics. So Steve is both bioinformatics guy, and from what I know about Steve, he is amateur mycologist and bioinformatics. He's had to learn the bioinformatics side of things. So when he says they're distinct, he isn't jumping to the conclusion of saying it's a different species. He's just saying the data set from this barcoding Sanger sequence is distinct from this one. He's not saying they're a different species. From what I've gotten from Steve the whole night.
So how do we correlate these things?
That is the fun part of the discussion.
Yeah, isn't that the biggest question?
That's
in all
the
of
fun
biology?
part of the discussion.
What is a species? There's all these different species concepts out there.
That's why my PhD involved morphology, DNA sequence, and biological species.
Yes, and I love that. I love that point.
I did that like 25 years ago. So y'all think you're like coming up with some brilliant new topic to discuss? This is in the literature. This is well established. This problem with DNA sequences and using different varieties of DNA, different portions, introns, exons. We've talked about this before in doing a podcast, but it goes over the head of most people. So if introns, exons, conserved, non-conserved, variable, etc., different analyses like Bayesian inference, neighbor joining, etc. Those all need to be discussed before we just start like throwing out ITS. It's like you've got to understand what ITS is, and the fact that ITS1 is flanked and ITS2 and you got large subunit 5.8s in the middle. Like we've talked about this, but like most of the listeners don't really they're not too into that. But when I hear people just saying, well, like ITS sequence is going to solve everything, but they don't really understand like what ITS is.
Hey, Ed, I'm going to tell you right now, Ed, Steve, I have not heard a single one of these guys say it's going to solve everything.
Yeah, it's like, what is it? Where's it even coming from?
I don't know where that...
Did you even listen to
anything?
I do. Listen to anything we just said in this whole podcast?
4 years, yeah, I've been listening to every word. Now, again, why are you insulting me? Steve, why are you insulting me?
Because you're sounding... Okay, I won't even go there. All I will say is that if anyone plays this podcast back, they'll listen to me say... I've listened to
every single fucking word.
I know. So I think if they play it back, they'll hear me say one of the first things I said is my goal is not to identify all these species, to put names on all of them. I'm not interested in naming them. I specifically said that. What I'm interested in is doing an outline of the biodiversity of fungi that's present through primarily ITS sequencing, and nanopore sequencing of the ITS region is going to allow us to get to that end goal far faster and far cheaper than any other methodology. You're bringing in all these other things that nobody's even talking about.
So what are you going to have, like the 2,000 bins of fungi in Indiana?
Well, we're at about 3,000 right now, so...
So you're going to call them bins? Like you're going to put a field guide together and be like, oh
no,
yeah,
it's an outline. It's not meant to be. It's not meant to be an end result. It's an outline, a preliminary survey, as we've talked about a number of times during this podcast, of the biodiversity that's
a bunch of ITS sequences?
Of the biodiversity of macrofungi that are present.
How are they diverse? Because they have different ITS sequences?
I mean, I can't even comment on that question.
Yeah, I would love if you could.
I'm sorry, MycoGeeky. I'm probably done with this podcast.
That's okay. I understand. Okay,
I'm
so...
sorry, man. Dude, you shouldn't attack me, man. This is not a... I'm trying to be professional, and you've insulted me at least 5 times now. I don't recall insulting you. I was talking about your work and your statements, and you personally attacked me. And now you're going to leave. Thanks.
So we're 3.5 hours in, and I've asked a couple times for the tone to be adjusted. It's probably a good time to just end the podcast. I think there's plenty of great stuff in here, and even though there's some tension here, I think there's still some good stuff underneath
dude.
all of this.
When you go through academia and you realize this is like, if you ever gonna stand up in front of 400 other mycologists and make statements, you better damn well know how to defend them. I'm sorry, if you're going to NAMA and you're giving a keynote speaker and somebody stands up and be like, hey Steve, I got a question, and you're like, well, not like, you better damn well know how to defend yourself. That's what academics do. You can't make broad blanket statements about this and that, and I heard about this. Like, you better damn well know your facts. Don't make statements you don't know how to defend. I don't. If you play this podcast back, you'll notice I haven't said a single goddamn thing that is erroneous, that I haven't had a reference to back it up. I have said nothing wrong. Now you're gonna be the one who's
Hey, Ed.
All right, sorry.
Okay.
Dude, you
Ed,
better get used to it, though, man. Get used to it.
Ed.
You think the shroomery is bad? Wait till you stand in front of 400 academics.
Wouldn't be my first time.
Okay. Here's my takeaway tonight. Man, us mushroom people, we just love our mushrooms, don't we? We just
I picked
love
the
our
wrong
mushrooms.
day to stop sniffing glue.
Anyway, all right. So thank you so much for being here. We never even got to talk about all the things I actually wanted to talk about in the segment. That's okay. We'll do that another time. I want to thank Stephen Russell, Harte Singer, Ed Gran, Damon Tighe, and Kyle Canan, who had to dip out at some point in time. He's got some young kids and all that. Anyway, it's been great, and look forward to hearing what you guys got going on for the rest of the year, and we will definitely put the good word out. I know Steve and Kyle can definitely use specimens, so anybody in the general vicinity, especially Indiana or Ohio, and you guys are out hiking and collecting specimens, if you want to dry them and send them to them, they would appreciate that very much. Anyway, thank you for hanging out with me tonight. Next week, we got the old rookie mycologist coming on, so we're going to talk about social media and how to own YouTube, basically. All right, guys, thank you so much, and have a great night.
Bye-bye. See y'all.
Have a good one.